and he is also an associate editor and editorial board member and reviewer of many international journals. And SAR has been awarded many national international fellowship like IEEE Senior Membership Award, JSPH Fellowship. And SAR has a Fellow of Royal Society of Chemistry, UK, and Fellow of Academy of Sciences, Chennai. With his broad knowledge and enlighten, I pleasure to invite Dr. S. Balakumar sir to take the online forum to enrich our participants. Sir, please.
Very good morning to one and all here. And, let me share my screen. Yeah. So can you see my slide? Right. Okay, sir. Right. Thank you very much for inviting me to deliver the lecture. At the outset, I thank the convener of the symposium or the workshop, Dr. Peryaswamy. And the title of my lecture is Zinc Antimonate, an advanced functional material for supercapacitor. So this is an outline of the lecture for next 45 minutes. So this is a primary research focus and the snapshots of our work, and also I'll cover the zinc anti-nanostructure that we have done in our lab. This is a maximum, Peryaswamy. I don't know where is the problem. Can you hear me? Hello? Hello? That's all maximum in my system, because I think, right. Right. So our primary research interest is more on materials, and then we focus on the functionality of the material, and then also we design and fabricate the multifunctional material, which is basically we call it as a smart multifunctional, where you fabricate the material, and using very simple approaches in the lab level, and also we work on the physical properties, and then application in energy and environment, and in particularly energy, we look at energy generation and energy storage. So these are the some of the materials that we are focusing. Generally, noble metal graphene composites, and also bioactive materials for biomedical application, metal oxide semiconductors for sensor and environment, and then magnetic quantum dot, and the materials for energy, and then particularly for supercapacitor, right? So when we discuss about these things, so particularly when you say the material for energy storage, so the one of the storage devices is well known. It is a supercapacitor, and then also the supercapacitor, and also they combine the capacitor and battery become a supercapacitor, and also there are many people working on EDLC and the pseudo capacitor. So, but now most of us, it is that we are trying to come out with a hybrid capacitor. So one of the materials that we have identified is a zinc antimonate. Zinc antimonate is a new material, a relatively new material, and one of our students has extensively studied this material, and at the first set, just he fabricated many different structures, and then he explored the possibility of to use it for different types of supercapacitors. So these are the snapshots of our work, what we have done in almost past 4 or 5 years, where we created starting from particles and nano flakes, and then the nano clusters, and then there are different types of nanostructures. Then we move on to the composites. Then the graphene zinc oxide composite, copper oxide zinc antimonate, as well as with the C3N4 and then C3Ag. So there are different type of composite that we have designed and fabricated it. Here, for this lecture, I'm going to share it's a few of our work. So lectures, we all know, I think you have been attending this lecture for almost 1.5 days. We know the supercapacitor has gained a considerable attention because when you compare to the other devices, it's a speedy charge discharge characteristic, with then high power density and exceptional cycle stability. That's why the entire scientific community is attracted to significantly enhance the power density as well as the energy density of the capacitor by exploring new nanostructure based multifunctional electrode material, right? So there are, yeah, we all know there are two different types of capacitor. One is an EDLC capacitor, which is known as electrical double layer capacitor, where EDL formed with the electrode and the electrolyte with the solvent molecule as a dielectric. So they store the energy by absorbing electrode ion onto the surface of the electrode. So what is an advantage? It is a fast active, but no energy potential. Energy is confined to the surface. So, but then another one is a pseudo capacitor that we all know. It is generally, it's primarily rely on redox reaction that takes place at the electrode. With electrode material made up of different types of material, we all know. But for pseudo capacitors, we use conducting polymers, transition metal, and compound with oxygen and functional groups. But they have very high energy density, but so low cycle life. So there are no. That's the reason people go for a hybrid capacitor by combining taking the concept of EDLC and the pseudo capacitor, and then they design the material. Such designed capacitor is one is known as a lithium ion capacitor, which is currently leader in the market, where they combine EDLC and pseudo capacitor to optimize the power density of the EDLC and then energy density of the supercapacitor. So that there, this gives more advantage over them. So there are many different types of hybrid capacitor. But we quickly look at the hybrid capacitor material. See, when you say EDLC, most of the material that are tried for carbon allotrope, based on carbon allotrope or actuated carbon. Whereas pseudo capacitor, we say metal oxide and conducting polymer, as I discussed in the last slide. But when they combine these two, you can combine these two group of materials. You can go for asymmetric capacitor or battery-based capacitor and a composite capacitor. You can also further develop and integrate it. So, but when you look at the material, we have there are certain material which is, as we mentioned, there are certain material for EDLC, but their capacitor and energy density are still low. Don't have a very high surface, okay, very high surface area and the pore size distribution, in particularly for carbon, but must be carefully tuned to accommodate electrolyte ion diffusion, where the surface area and morphology makes sense. Hence, an economical supercapacitor with better electrochemical is essential. Pseudocapacitor can accomplish a much higher capacitance than EDLC, but they suffer from decrease in cycle stability. So there are two different kinds of material, as we said, conducting high specific capacitance, but they suffer from swelling and shrinking owing to the the charging and discharging cycle. That certainly lead to the very short lifetime. On the other hand, metal oxide possesses higher surface area, but and supports ion depletion onto the material. But the metal oxides are expensive, very hinders the commercial usage. So, when you look at the emerging research direction, so this is as we discussed, combination might work, but you have to optimize the one. So, one such material is a zinc antimonate. Is a zinc Sb6O7 antimonate. It's a tetragonal in structure, semiconducting material, N-type semiconductor, bandgap 3.1. Wide it is demonstrated as a photocatalytic material and gas sensor. But it can be explored based upon the nature, because interference of multivalent ion could yield better electrochemical property, and that was reported earlier. So, but there are also one report earlier, it shows that they have already used it for lithium ion battery, because this they also demonstrated that it is one of the promising alternatives to commercial carbon metal in lithium ion batteries, because your specific capacity is relatively higher at, at 0.1 milliamp per centimeter, and long cycle size, and the superior rate performance, and even after 300 cycles. So it is there. But it is that such properties is certainly attributed to the insertion process and conversion and alloying reactions as well as pseudo-capacitive contribution. So fuels is also fabricated. Now let us see what we have done it. So what we have taken is we have taken zinc antimonate material and look at the strategies of the approaches that you can do it in the lab level. So it's obviously we all know either you can buy soluble or precipitation or hydrothermal. We tried with the two different approaches. One is what is with precipitation and other with the hydrothermal. So what we have done when we use a precipitation technique, so with it is depend upon the stirring condition. There was a beautiful changes in that. The stirring condition changes the morphology and subsequent annealing also morphology. So the annealing temperature that we have decided depend upon the thermogravity curve, the weight loss during the thermogravity curve. So that is yielded two different material with the two different morphology, which is are called nano rod and the nanoparticle. So that is also FDA shows that the presence of the OH molecule on the radioactive group. But you will see when you want to work on a material, and the people don't go for as a material scientist, as a physicist or chemist, before we go into the application, please pay attention to the material preparation in the sense how do we control the size and the morphology. So what are the parameters? How you can control the shape, whether pH or annealing temperature or nucleation temperature, and then you look at how you prepare the composition and in what way you want to integrate the material. If you understand everything, then definitely you can tune the material to get the right architecture and serve that primarily yield with the material with the defined properties. So this is one of the examples in Wilhelm Barak that we demonstrated. So we follow such a strategy. So for any material, so zinc antimonate, we showed one is spherical and other one is in a rod shape. The average particle size and rods are different depend upon the ultrasonication, but both the show single crystal nature based upon the series pattern and HRM 10 studies. But when you look at the band gap is very good. It is relatively lower for your rods with 3.72 and 3.93. But though there is maybe the rod, maybe the band gap may be on the, I mean, it's relatively on the, it should be on the higher side, but the morphology is relatively bigger. So that's the reason the band gap, though have a confinement, it is again, so it is still we have a lower band gap 3.72. But the PL studies predominantly is a purple emission beam that can be used for LED application as well. So then subsequently we have carried out the electrochemical analysis. So to the pseudo and it shows the, and if you look at the curve, they have a very good electrochemical stability and the rate stability. And while increase the current or the sweep rate, it maintained the shape of the curve. So that shows that pseudo curve. And also you look at the GDS curve, that is again further confirmed that it is the charge discharge curve. It clearly indicate that the pseudo-capacitor. So from this data, we have calculated that in the specific capacitor, it was very low for a particle and relatively higher for the nano rod, which is 53 farad per gram. That also we have published. Then we moved to the recyclability, I mean the capacity retention measurement that is highly stable, 100% is there. And the noise, the Nikos class, so Z prime, you can see that whether it's a linear curve in the lower frequency region, but certainly exhibit that high conductivity and capacity nature of zinc antimonite. Okay. Then similarly, we look at, in order to look at the stability and the phase angle, we did Bodo flat before cycling and after cycling. That is also the Bodo angle is very close to 90. So this shows that the inclusion of two heterovalent ions in the nanostructure exhibits pseudo-capacitance behavior. So we have to know that pure antimonate is pseudo-capacitant in nature. But the stability is there. It is possible to increase the material and the capacitance of the material, both the board angle is above, one is 90 and another one is minus 55, which represent the stable ionic transport rate ideal capacitor characteristic. So that has been chosen, this was chosen to make a nano composite. So we all know graphene is one of the well-known two-dimensional structure of an allotrope of the carbon, where always you can, if you functionalize it and integrate it, so that can be a very good composite, and the ratio and the nature of the electrostatic, the nature of the interaction and the composition, that all depend on our requirement. So just because of the superior mechanical as well as electrical conductivity of the graphene, we have chosen this material, and we have systematically evaluated it. So what we have done is, we know that graphene can be prepared in many different ways. It can be by CVD, it can be epitaxial, and the lab level. And for research, we are using modified Hummer's method and the mechanical exfoliation. But what we have done is, we want to try with a less acidic environment. We want to do it with less acidic environment, in the sense, instead of using oxide to detach the graphene layer from the graphene, we use some different solvent. That is that we use primarily we use the sonochemical approach, and then we use different. We didn't use any acid. We just use simple water, glycol acetic acid, and ethanol, and it's a very simple, not time consuming process. What you can do is, this material also can oxidize it and reduce this. It can also break the molecular wedges and then functionalize the surface. And the stability of the graphene can be maintained. So that purpose, I mean, that was done by classical acetic acid. On the other hand, ethanol is the one on the functionalize on the surface support to maintain the stability. So that is we have demonstrated it. So certainly, when you do with ultrasonic wave, molecules to penetrate deeper inside the graphite flakes and exfoliate individual layers. So the out of the plane, the COOH group is very essential in achieving such a stable dispersion of graphene. Moreover, the ethanol possesses a similar structure as acetic acid. It supports long-term suspension stability. So this combination of glacial acetic acid and water, ethanol, and ultrasonication power and the time and the frequency, obviously that yield the material, the graphene, and that we also published in Journal of Materials Letters. Later, it was also highlighted in Hindu. It's one of the cheapest method that you can prepare graphene. So you can also try this method, and it is one of the viable process. So you need not to use acid all the time. Then we take a graphene, and then we have taken the precipitation method gel. Then we can we mix them. Then we go for a reduction, and that one. What we have done is, so this one it is yielded where politically we take nano rod morphology. Nano rod embedded under graphene. So that our preliminary characterization demonstrated that zinc antimonate is a decorator on graphene, and also this is the peak, along with you have a 2D peak. So that confirms. So you are decreasing the your T and G ratio, the interaction of a nano rod with the graphene. So that shows that has certain interaction. It may be electrostatic, or it may be, since you have oxygen, it is possible to have a carbon, oxygen, and zinc peak. So that is also confirmed in the later stage. And when you look at the morphology, their wrinkled seeds were obtained, and you can see that you have some 7-layer stacks also obtained. The single source hexagonal the imaging in the hexagon. Then the particle decorated is all it is stacked in between the layer. That certainly detached the layer and maintained the stability. So then we took the DRS study. DRS, you have a zinc oxide, zinc antimony is 400, but whereas when you combine with the graphene, the absorption region expanded. But that when you do the PL, only for the charge recombination for zinc antimonate is very high. But when you combine with the graphene, it is completely, there is no recombination at all. So that is certainly shows that. Then as I mentioned in the XPS, you can see that this is for the carbon, graphene, and this is for a metal oxide. So you have a peak of carbon and oxygen and the zinc antimonide. So there is the peak up here. I mean, it is there. So it confirms that this is it is a chemical interaction between the material. So that we have also systematically evaluated the graphene electrochemical properties of the graphene that we have fabricated, and which shows that EDLC behavior. You look at the electrostatic curve, so that is maintained. You don't maintain the shape, and also your charge discharge have a symmetry in structure. The specific capacity was 49, but whereas this is 49, we know that pure antimatter is only 50. But when you combine these two, you can see the hybrid material, which is end up in giving the red charge, giving you can see that it is the capacitance value is tremendously increased to 1470 farad per gram. This is one of the strong evidence that the chemically combine it, you can get it. So there are the discharge time is more for in graphene zinc antimonide than with a different concentration. Superiority of non-aggregation of graphene sheet, incorporation of metal oxide on the graphene, controls the aggregation of sheets and keeping the surface area of conductive susceptible to the electric ion. So high value. Synergistic interaction between the graphene and the nano rod are given. So electrochemical studies of graphene and the zinc oxide composite are, you can see that still your retention is very good. It is 98% to, and for compost it's 100%. So the Nyquist plots also shows that you have a very good stability reaction, synergistic interaction between graphene and zinc oxide. The Bordeaux angle both are very close to -90. That confirms that this material can be used for further evaluation. And so what? The second thing is that we have taken the surface pure silver. Then we also use a very simple approaches to decorate the silver. When you decorate the silver, because silvers are a noble metal, one of the noble metal, have a quite lot of free electrons. That when you anchor silver on this AgN mode in the zinc antimonide, that will certainly improve the electrical conductivity of Ag, because it is Ag, the electrical silver is 3 to 5 times harder than carbon material, right? So when the silver Ag composite fabrication to the ultrasonic process, we have done it using the ultrasonic, very simple process. We take a zinc nitride and the zinc annular particle. Then when you reduce it, the particles are decorated on that. That is confirmed by your FTER, the presence of also with the XRD, the silver is there. Then XP is also further confirmed the peak for silver. That shows that. So we also that morphological studies, and then also the high resolution images from HR10 is evidently shows that particles are beautifully decorated. Ag nanoparticles are decorated in the large size zinc antimonide particle, and the length of the particle, that means certainly the formology of the particle decreases. I mean it is there in the range of there, but the band gap decreases with increase of Ag from 3.2 to 2.71. That certainly shows that electrical conductivity of the Ag changes the band edge position. So that has been done. And then that is again it is confirmed with optical characterization, the absorption increases, PL intensity, the recombination is not fully reduced, but the band gap is drastically reduced. So that shows that the PL peak intensity decreases in concentration 1 to 3 mole to 5 ml. Okay, this is the one. Second thing, electrochemical characterization. It shows a EDLC. I mean, it's actually you have it is a pseudo capacitive behavior, and then the redox potential. Then during the oxidation in reduction, silver become a Ag plus silver ion, then also become a silver again, the zero silver. That is by charging and discharging mechanisms. So the CDS curve and the capacitance values. I mean, these charge discharge curve also beautifully shows the capacitive behavior. But whereas in the relatively compared to the earlier material, your capacitance value is less. But it is possible to combine silver graphene, zinc antimonide. That certainly it is expected to increase by double. So the cycle stability is good, and the Nichols flat and the board angle curve confirm the superiority of the material. So this is the another work what we have done is that we have taken silver, molybdenum diselenate. Molybdenum diselenate is one of the well-known material which has an hexagonal structure involving covalently bonded SMOS by relatively weak van der Waals forces. But it has a reduced surface active surface area, capacitance, electrical reduced conductivity, rapid capacitance trading. It is all there. So when you combine these two, they found we have a certain application. So what we have done is by ultrasonication process, the MOS break into MOS nanosheets, then we combine with the zinc acetate, then we make a zinc antimonate with a different ratio, 1:1, 1:2, and 2:1. We found that MOS2 is decorated on the rods. So that shows that. So then the structural studies confirms that, and the transmission also the presence of the metal that the intensity of the peak changes with the composition ratio. Then when you increase the ratio, the more number of particles are decorated on the flakes of MOS2. So that is also you can see that that is your nano rods are stacked between the layers of MOS2. So that is also we have submitted accepted ultrasonication chemistry. So but the UV spectra and the band gap, the band gap is also decreased to 2.64 and also reduced down to 2.38 with different MOS2. So the XPS analysis shows that the presence of electrostatic interaction of this material. So and then subsequent studies it shows that your MOS2 or the combination of MOS2 are having a pseudo capacitive behavior in nature, and the discharge time is comparatively higher in the case of MOS with the lower concentration of zinc oxide. So the reason behind higher charging time can be attributed to the formulation of fuel stacked layer without restacking effect and the presence of sufficient amount of zinc oxide, zinc antimonide nano rock. So this is also one of the very good composition. Further studies on the specific capacitance resources which also comes around 200 and cycle stability is 98%. So the Nichols flat and then Bodo cycle confirm the stability of the material for that and then the maximum capacitance results in everything. So in general, if you look at it, zinc antimonide is very strong material. When you combine with MOS2 or the AG or copper oxide, it's possible to do it. I think the same thing. So in overall, what I can do is we have taken this material nanoparticle and the nano rod and the zinc antimonide and the graphene nanoseeds and composites, and along with an MOS2, we also combine with, I'm not showing that copper oxide and C3N4 data, but we have used almost two different electrodes, depend upon the material, 2 to 3 different electrodes. But if you look at it overall, the specific capacitance and the stability is there while combining graphene with that. So the graphene is such a beautiful material where you can see, that some of the pure is only 14, and when you count the the morphology changes, it is almost tripled. Then AgM conductivity is good, but pure graphene 49, but chemically interaction, it increases to 1,000, around 1,005, very close 1,500. But other values are below low, but we can choose which is better. For example, your C3, the carbon-based material, the C3M4 also bringing this one, but again depend upon the morphology, it can be possible to vary. But you can also make a ternary composite where this also can be further increase the specific capacitance and also electrochemical cell. So overall, it is a very strong evidence that novel, economical, and efficient electrode materials can be designed with a zinc antimonide, which we are doing it right now. We are working with the device level, and we have published, a dozen paper on this material. Especially my student Bala will did this, and they have published very good papers in the papers in ultrasonication chemistry and electrochemical acta and the material structures, semiconductor processing, and all. And so this is basically one of the very good work what we have done on supercapacitor. Now we are extending with the C3N4 and then graphene. So we are fine tuning the material, and also we are making ternary compound And if you people interested, you will also happy to share our results. You can also continue on that. So with this, I can thank the opportunity given to me, and also I thank the funding agencies and my chief, because it is not one person cannot do all this work. And certainly, credit goes to my students who other have ability to do everything systematically with the discussion. Now they are done. Also, they are independently. They contribute a lot. So with this, I can thank the organizer for giving me this opportunity. Now the session over to the Telusani for discussion. Yeah.
Sir, good morning, sir.
Good morning, sir.
Sir, thank you so much for nice presentation.
Yes, sir. Please.
Sir, I have doubt. Actually, how to choose the electrolyte for the materials? Sir? Electrolytes for the materials. Actually, it was
Electrolyte. You see
complex.
the
Yeah.
electrolyte again. You see, what is, and you have to make sure that let me see. I'll go to the slide and. Electrolyte, we have a only limited option. So electrolyte, it is whether you are this again. For example, when you use H2SO for MOS2 and MOS2, the stability of the material is not there. Stability of the material, because the reaction, it is also changes the nature of the material. Of course, and everything by experiment. But in my view, when you use graphene based go if you look at the carbon based one, you can use sulfate based electrolyte. So and if you ask me the criteria, I am not very sure about the criteria, but I know that the KOH or NaOH solution dismantle the carbon structure that we have found it, and it is a relatively very strong acid. So and then for oxides and all, KOH is fine. Even in fact, we evaluated zinc antimonide with the KOH and the electrolyte. I mean, this H2SO4, but H2SO4 results are relatively stable. This depends how the stability of the material in the electrolyte. That is actually one has to do by evaluation method. But based on our study, I understand that sulfate-based electrolytes are good for carbon-based material. And then for metal oxide, you can go for KOH. So that is my experimental evidence.
Okay, sir.
Thank you. Thank you.
Thank
Next
you.
question.
So may I ask one question?
Sure, sir.
Actually,
Why not?
you gave a wonderful presentations.
Hmm.
So I have see in the summary slide the best performance graphene based zinc anotides
Right.
nanocomposite will deliver a stability of 106 point something.
Hmm. Hmm.
So
Hmm.
can you evidence that? Can you please give the
That you
evidence?
are talking about 106, right? That is always a very good question.
10 stability after 2000 cycles. So
Yeah.
it is greater than 100%.
Yeah, greater than
Uh,
100%. See, 100% means what is the value that makes it that you have 1470 is an 100%. Sometimes there are, there are surface charges is increasing depend upon the nature of the electrode. But if the surface charges are, it will not, it cannot be, it may be, sometimes it may be due to your, the surface energy of the material in the higher side, that is also contributing. But this is a real value that we have obtained. It is not 1470. The charging efficiency increases because of the reaction with the electrolyte. But on the other hand, you have to make sure that the reaction should not deteriorate the material, but it can increase the surface charges. When you can increase the surface charges, the surface of the material, if it is the energy of the surface is increases, you can do that. So one is the charge and then the energy. Then how these two can increase? One means the surface defect is increasing. So that is an indirect evidence that surface defects increases, that is etching increases, you can, but it cannot beyond a certain time. It may go to 105 or 100, and later it may come down to 100. It was stable up to 100. So that's actually a surface defect created on the surface of the material. That will contribute, further the beyond the 1470, maybe 1500 also it can go. Clear?
Okay, sir. Thank you, sir.
Thank you. Any other question?
Sir, I have another doubt, sir. Actually, now the people who are working on metal organic framework and the covalent organic frameworks is compared than transition metal oxides. Is there anything important on that, sir?
For metal organic framework, you can engineer the material, you can easily tune a new material. Okay. So down the road, if you look at it, they will also say metal oxide framework is a new era of material they are working on. Later, they are also see next they are working on 2D materials. MXing they are working on it, and then there are many group of materials. Only we are evaluating a relatively better material everywhere. That's all.
Okay.
That's it.
Thanks.
Okay. Any other question? Sir, over to Periyasamy, sir. Thank you, Dr. Periyasamy. I also thank you and for giving me this opportunity. I also thank all the parties who stayed with me in this session for 1 hour. And thank you once again. I'll formally leave the session. Thank you.
இன்னைக்கு அனுப்புன மெயில கனெக்ட் ஆனா போதும்.
Hello. Sir, good morning, sir. Can you hear me, sir?
Yes, sir, I can hear you, sir.
Okay, thank you, sir. Thank you very much. Okay, sir. Thank you. Sir, okay, sir. We can start.
Good morning to all. I'm very happy to introduce our resource person for this session. It is my pleasure to introduce keynote speaker, Professor Dr. R. Gandhi, working as a professor, Department of Tripoli, and as serving as Vice Principal, Nyanamani College of Technology, Namakkal, Tamil Nadu. And he obtained his PhD from Anna University in the area of IoT, and he has rich knowledge in IoT applications in biomedical, electric, and healthcare appliances. And he has one startup company named as Raga Technologies from manufacturing electric vehicles. And he has total teaching experience of 18 years and 3 years of industrial experience, and he has published more than 15 international journals in the credits, and he registered 3 Indian patents in the area of IoT and electric vehicle. So far, he delivered 18 keynote address in the various technical workshop conducted by the various institute, and he conducted totally 20 webinars from the benefiting students community. With a brief introduction, I would like to invite Dr. R. Gandhi sir to deliver a seminar lecture on the opportunities and challenges in e-vehicles. Sir, please.
Thank you for your intro, ma'am. First of all, I want to thank Nehru Group of Institute for providing this opportunity to share my things with our group. Good morning to all. I am going to handle this session with your permission. Very some, sir. Shall I? Okay. Thank you, sir. So I want to thank the principal sir and Professor Periswamy for providing this opportunity. So now I'm going to present my session. Periswamy sir, my slide is visible for you. Okay, thank you, sir. Thank you. So once again, I want to welcome all the participants from various institutions. Good morning to all. Now I am going to start my session. Already the resource introduction, they are giving the intro about the need of electrical vehicles. I slightly change the title, switch to electrical vehicle. It is the need of 21st century. Why? Because two reasons are there. One is the fossil fuel cost is increasing, then demand also high. The next one, due to the technological development, we want to switch the electrical vehicles. So these are the two reasons we are move from fuel vehicle into electrical vehicle. So the history of transport system, it is introduced by 1662 year. We are using horse as a transport system. Then we are introducing trolley system in 1882. Then The first motorized bus is introduced in 1895. After that, the buses are introduced in 1965. Now it is a 21st century. We are slowly move from fossil fuel to pure electrical vehicle. So this is the basic scenario about the transport system. So once we want to switch over the electrical vehicles, so these are the benefits. Once you are choosing electrical vehicle, the first thing we can eliminate the carbon emission, then clean energy, then noiseless operation, easy to charge. These are the advantages while we are going to electrical vehicle. So generally the electrical vehicles are classified into 3 categories: a battery electrical vehicle, hybrid electrical vehicle, and fuel cell electrical vehicles. Dear friends, nowadays instead of petrol vehicles or diesel vehicles, it is called IC engine. Instead of IC engines, now we are switched to these kind of electrical vehicles. Now I am explaining one by one. Even in cycle itself, now we can use electrical cycle. Then coming to the point of two-wheeler like moped or scooter types, we are using 2 kind of electrical vehicles. One is called hub type. The first top side you can see hub type motor. What we are using in the road line. A hub type motor is nothing but the wheel itself, the BLDC electrical motor is inbuilt in the bike. It is called hub type motor. Then you can see in the right side corner, this is called, you see the cursor point, this is called chain drive, otherwise it is called mid drive motors. So generally 2 kind of motors we are using. One is called hub motor, another one is called chained motor. In hub motor, a lot of companies like Okeniwa, Ampere, a lot of Komaki, all are the brands are using hub motors for electrical vehicles. You heard about the Aether vehicle. Now that they are going to launch in Ola also, they are using mid drive. Mid drive means the motor is placed in the middle side. Then using chain or belt drive, they can drive the motor. So 2 types of two-wheelers are now going to occupy in the road lines instead of IC engine. Then third one, it is quite interesting. Instead of auto, we are replacing the petrol IC engine. We are using electrical vehicle. In this case, we are using 3 kilowatt motor to replace the IC engine. This auto also classified into 2 categories. One is called normal passenger auto, another one is called e-loader. So in e-loader applications, mostly they are used in corporations, municipality, and as well as in bricks manufacturing companies. They are using this kind of loaders for their applications. Then quite interesting, you can now in Chennai also Ashok Leyland launching the electrical bus for our Chennai Corporation Limited. Purely it is operated by battery. So this is one of the advantage. It is running in Tamil Nadu itself. Then in foreign countries they are using flights also. And another important electrical vehicle parameter is called drone. So you know very well the application of drone. Now it is used in the monitoring purpose by using traffic and other applications. And also now it is the big trending technology. It is going to implement in the agriculture purpose. So this is the simple kind of applications where we are using the electrical vehicles. Other than that, a lot of four-wheelers like cars are going to occupy in our road line within a decade. So these are the companies. They are already they are having the testing. Testing is over. Nearly the speed is it is achieved nearly 200 to 400 kilometers. Then mileage also it is very high. In our Indian road line now, I think two companies they are already successfully launched the cars. So one is called Hyundai. Hyundai already Kona they make the Hyundai car. Then next one, you know very well about the Tata Nexon. So Tata Nexon also one of the pure EV is available. It will give 400 mileage. It is similar to IC engine, but the salient feature is it's a noiseless operation. Then it is not emitting the carbon. So these are the main advantages of the electrical cars. So some of the companies they are going to launch this kind of cars in our global. So this is the spec about the Ashok Leyland, e-bus. Then Hyundai Kona already I told. Then Mahindra already they launched its e-Verito. Then E2O also Mahindra brand. Then Tata I already sold. Nexon is already there. Then Taigo is one of the commercial purpose that they are going to launch the electrical cars. Then coming to the picture, compared to existing petrol or diesel engine, we are switch over to electrical bike. It having minimum parts. That is the main advantage of electrical bike or car or four-wheelers or trucks. The main advantage of the system is we are using less components. For example, you can consider any two-wheelers, minimum 1000 components are involved in the IC operations. Or that is the main drawback of the existing system. But while we are going to switch over to electrical system, that is the need of our in country. Only we are using 5 important components are used in the electrical bike. Namely, first one is motor, then second one is battery, third one we want to control the motor, we are using controller. The controller input is given by throttle. Then fifth one is called DC to DC converter. Dear friends, this is very important point because a DC to DC converter need. What is the need of this DC to DC converter? All the batteries are the minimum battery capacity of the vehicle is it starts from 48 volt, 60 volt, and 72 volt for two wheelers. But all the two wheelers lighting system and horn and other applications are operated by only 12 volt. So that is the need. We want to step down the DC to DC voltage from either 48 or 60 or 72. This reduce it to 12 volt. So what is the application of DC to DC converter? The DC to DC converter is used to reduce the voltage from the battery to lighting systems and horn systems indicators purpose. So this is a main important point. That's the fifth. Five components are mainly used in the electrical bike. Compared to IC engine, it is very less components. So what is the advantage of the system? The advantage of the system is maintenance is very low. So maintenance cost is very low means the people they are like going to switch over to electrical vehicle. Then sixth one, it is a parameter. It is used to know as a meter. The meter is used to find out the battery indication, how much of the capacity battery remaining in the vehicle. Then what is the speed of the vehicle we want to monitor. The next one is kilometer storage. All the things are monitored by the meters. So this is the main parts. So quite interesting. Why the people they are switch over to electrical vehicle means these are the simple parts are present in the vehicle. Like already we discussed about the things. Here you see this is battery. So this is the main important point of the vehicle because While you are going to buy the motor, buy the vehicle, 40% of the cost is bad to battery. So that is the main drawback also, because you are going to buy a vehicle at the cost of 60,000. 40% of the cost we want to bear for the batteries. So why we are choosing this title means because now lot of researches are going on in the battery sectors. Now in current trend, what are the batteries are used in the electrical vehicle system? One is called lithium ion, another one is called lithium ferrophosphate. These two cells are used in the batteries. In coming years, maybe the past sessions and future sessions, they are going to telling about the supercapacitors and aluminum air batteries. Then in naturally, they are using aloe vera cells also. So a lot of researches are going on regarding this battery technology. But in the current scenario, these are the main components used in the electrical vehicle. One is called battery, and second one is called controller. Second one is called motor. Motor is depends upon the application. We are using different kind of motors. For examples, I want to control the speed of the motor. I want to use one electronic type controller. It is made by electronics components like MOSFET and other electronics controllers with microcontroller chip. Then what is the use of this throttle? The throttle depends upon the throttle point output. The controller desires the speed of the motor. Then this is called DC to DC converter. I already told what is the use of this DC to DC converter. Here the battery voltage may be vary from company to company. Suppose I'm using any one of the company, it is operated by 60 volt, but I need lighting on RN 12 volt. So this DC to DC converter, what is the use of this one? This 60 volt is reduced into 12 volt. That voltage is given to the lighting and RN. Then we want to monitor all the parameters. We are going to use them digital meters, which is used to measure the battery capacity. Then how many kilometers you want, then fast of the vehicle. These are the application of digital meters. Coming to the wiring connections, even we are not studying about the electrical fundamentals, but we can design the, or we can monitoring the, otherwise we can trace the fault occur in the electrical bike. Dear viewers, please see this diagram. It's very simple one. You see this is battery, this is motor, then this is controller, this is throttle, this is controller, this is ignition key. These wirings are only available in the electrical vehicle. Before that, it may be felt the connection diagram is very complicated in the design of electrical vehicles, but it is very simple. You can just see the diagram. You can I can easily understand the things. This is the brain of the vehicle, that is called controller. Then this is the drive, what we are going to use as a wheel. Then this is the accelerator. Then this is the on-off key. This is the battery. So you know very well how many terminals are available in the battery. What is the use of this battery? A battery is a digital storage, DC current storage element. We want to store the DC supply. So it is having two terminals, positive and negative. Then according to consider the hub motor, nowadays a lot of motors are available, but I am going to explain about the BLDC motor. Mostly electrical vehicles now used in the road lines. Most of the vehicles are they are using BLDC motor. What is mean by BLDC motor? BLDC motor is called one type of special motor. It is used for the applications of EV tracking. It having three main wires. You see this picture. This yellow and green and blue. These three wires are act as a main wires in the motor. Then remaining five wires are there. These five wires used for sensing the position of the rotor. So this is very important thing. In this motor, we are using Hall sensors. So what is the use of sensor? The sensor is used to sense the data, then it is converted into electrical. That electrical signal is given to the controller. So what is the use of these sensors in the motor? it is used in the motor itself to identify the rotor position. So it is very, very important. What is the use of the sensor? Here we are using three sensors, like you see the first three dots. These three dots are sensor output. These two dots are, we are giving 5-volt supply to the sensors. Whenever you want to activate the sensor, you want to give the supply. So first five lines, first three lines are sensor output. Then the second two dots are red color and black color is used to give the input supply to the sensor. So totally, how many wires are present in the motor? Yeah, it's very simple. Totally 8 wires are present in the motor, 3 wires for main supply, then 5 wires for sensor output. These all the wires are connected to the controller. Then after that, we want to connect the plus and minus battery to the controller. Then I want to adjust the speed. For that purpose, I am using one sensor that is called throttle. A throttle also acts as a sensing device. It having 3 wires. I already told each and every sensors we want to give 5-volt supply. So consider these 3 dots. 2 wires are given to the throttle. That is nothing but plus and minus 5-volt. Then depends upon the throttle position. You give the acceleration, the third pin, it will give the output. According to the output, the motor speed will be controlled. Then one more parameter, we want to on off switch. So you can see this wire. This switch is connected series with the red color wire, that means battery positive. That's all. This is the simple wiring connection diagram for all the existing electrical vehicle. So the design of or connection diagram of the electrical vehicle is very, very simple. Only here 8 wires, then here 3, 11 plus 3. Only 14 wires are needed to run the electrical bike. So please understand, it's not a complicated one, it's very simple one. So operating and connection diagram, it is very simple. So this is the overall picture of the electrical vehicle, you know very well now. So here in bottom side in green color, this is battery. Then in rose color, we are using middle drive motor. Previously I told that is called hub motor. Now you see here they are using motor. That motor is coupled with the rear wheel using belt or chain. So this is one of the example is called now you can just Google it, Ather. So Ather electrical bike, they are using middle drive motor. Then bottom side of the battery they are using controller. Then here before the headlamp they are using DC to DC converter for convert the existing voltage to 12 volt. Then headlight and throttle. So this is the structure of the electrical vehicle. So this is about the what are the types of motors used in the electrical vehicle. Mainly depends upon the supply. Existing scenario, we having two supply. One is called alternating current, another one is called alternating supply, another one is called DC supply. So one of the main advantage is we can store the DC supply, but we can't store the AC supply. That is the difference between AC and DC. Using battery, we can store only DC supply. You can please understand. Those who are non-technical, please understand. We could not able to save the AC supply. We are using battery means we are having the only chance to store the DC supply. But how we can use AC motors in electrical vehicle? Once we want to convert the AC supply into DC, we can store in battery. Again, we want to invert that one, DC to AC. That AC supply is given to the motor. The AC electrical vehicles are run. You heard about the Texas. Tesla is one of the branded electrical vehicle in US. They are introducing the electrical cars using AC motors. Normally in our two-wheelers we are using DC based motors, but in cars and all they are using induction motor, that is come under AC motor. Then coming to the picture of DC motor, it is classified into two categories. One is called the PMDC. PMDC is nothing but permanent magnet DC current, DC motor. Then another one is called BLDC motor. So what we are using in the two-wheelers, we are mostly using BLDC motors, but in cycle and one more applications like buses, they are using PMDC motors. Coming to the picture of BLDC motor, we are again it is classified into two categories. One is called hub motor, another one is called chain drive motors. We already discussed about these things. Then coming to the AC motors, it is classified into several categories. A lot of motors are there. Induction motor is one of the main application. Then permanent magnet synchronous machines also now it is available in the scenario, available in the market. So this is the kind of motor. It is normally you know very well about the basic operation of motor. When you are giving the, we are placing the magnet, then we are insert one conductor. Whenever we are giving the supply through the conductor, automatically due to Faraday's law of electrical things, it will rotate. So this is the basic operation of BMDC. But mostly we are using this kind of motor. This is called hub motor. These hub motors are used in the electrical vehicles. These hub motors are made by BLDC. BLDC is nothing but the DC supply is switched into three phases. That three-phase supply is the DC supply is converted into three phases. We want to energize the two phases, then we want to shift to two phases. It will rotate. So BLDC motor is nothing but it is a switching operation based motor. What is the advantage of this motor means? Here we are using Hall sensors to identify the rotor position. So what is the need of the rotor positions and other things? Depends upon the rotor position, we can control the speed in accurate manner. That is the main advantages of the BLDC motor. What I am saying, we can control the speed, but because you can consider the motor will take 1 second for one revolution. We want to mention the starting point and ending point. It will take 1 second means one revolution. So I want to identify whether it is complete one complete cycle is over or not. I am using Hall sensor to identify the things. So that is the main advantage. We can control or we can stop the motor in any position. So that is the main advantage of the BLDC motor, what we are using in the electrical vehicles. So now we can understand what type of motor they are using in electrical vehicle. BLDC motor with the help of Hall sensors. So once they are going to launch the motor, they are doing lot of testings. What about the current, torque, speed, all the parameters they want to check. Then after that only they are deliver the motors. Before that, suppose you consider the motor, the motor power may be 1200 watts capacity. They are giving different kind of voltage, then they are giving different kind of load. They want to test all the parameters in the industry. Then they are giving, depends upon the data sheet. You can easily understand the vehicle performance. This is the specifications of 1200 watts BLDC motor. The torque of the motor is 17 Newton meter. So this is the technical data sheet for the motor. Suppose you are going to assemble any one of the vehicle, you want to go through this all the technical data, then you can purchase the motors for your vehicles. I already told several number of parts are reduced in the electrical vehicle. The main part is, I already told, motor. Then second important parameter is called battery. The battery is the main and heart of the electrical vehicle. The cost also is very high compared to all other equipments. So we want to discuss about the battery because this is the right way, right time to discuss about the EV batteries. Generally, several number of batteries are available in the market. olden days, electrical vehicles are not familiar in the road line. The reason behind that is, one is there is no battery technology. Then second one is there is no electronics component development. So these two things is the main reason. Even you know very well, in Coimbatore itself, 20 years back, the startup company like Ampere is launched the EV before 20 years, but now they are in the market. But last 10 years they are facing a lot of struggle. The reason behind that is they are using lead acid battery for electrical vehicles. Then controller designs also very poor. That is the reason the electrical vehicles are not famous in last 2 decades. So second one, after the introductions of lithium ion batteries in electrical vehicles, now the electrical vehicles are become famous. One of the another reason is the fuel cost is very high, so that's why the people they are trying to switch over the electrical vehicles. Then one more battery you know heard, it is called fuel cell. Fuel cell is also, it's a very costly battery. The people they are doing the research to reduce the cost. Once the fuel cell introduced means it will most benefit for our peoples. Dear sir, can you hear my presentation, sir?
Yes, sir, we can hear you.
Please, anyone?
Yes,
Okay,
sir,
thank you,
we
thank
can.
you. Okay, sir, thank you, sir, thank you very much. Due to fact, I want to tell the things. Olden days, we are using these kind of shield batteries for electrical vehicles. The one of the main drawback of the lead acid batteries is one is called a duty cycle. So what is mean by duty cycle? The common people, you want to know the parameter before buying the vehicles. What is duty cycle? Duty cycle is nothing but the battery is, once we want to charge fully, then we want to discharge fully. So this is called one duty cycle. So people, please understand the things. The battery life is calculated by duty cycles. So what is my duty cycle? The battery is full charge. It is called full charge. After that, we want to discharge the battery. It will called one cycle. So in this lead acid battery, the duty cycle is only 600 only. The quality batteries, it will give 600 duty cycles. Then second drawback is the weight of the battery. You consider in the lead acid battery, the operating voltage is maximum 12 volt. Please understand. Once you are going to consider the battery, we want to consider two parameters. One is called input voltage, another one is called battery capacity. So once you are going to buy any one of the battery, just you can go for the electrical shop, then you can ask, I need 12 volt battery. The people never give 12 volt battery. They may ask one more question. So what capacity you need? So that is called AH, ampere hour. So once you are going to decide the ampere hour, only they will give the batteries. So you can see in electrical vehicles, the ampere hour is the main component to related to the mileage. So using 24 volt, 12 volt, 24 Ah battery, it will give, for example, 48 kilometer means instead of that 24 Ah, I am going to 33 Ah, it will give 66 kilometer mileage. So understand from this, while you are going to increase the battery Ah, more mileage will obtained by the vehicle. So, but the main drawback of the system is weight of the battery. You see here 24 Ah is 7 kg, then 33 Ah is 12 kg. Suppose you see the 12 volt 75 Ah, the weight is 12 kilo per battery, but 95 Ah 13 kg. You see, this is the maximum voltage by the battery. What is the voltage level? 12 volt. Electrical vehicle, I already told, in any kind of two wheelers, dear participants, please understand the things. In any kind of two wheelers, we are operating the vehicles by 48 volt or 60 volt or 72 volt. So these voltages are used in the electrical vehicles. For example, I am saying I am using 48 volt bike. So I'm having only 12 volt batteries. So what can I do? You know very well about the things, fundamental things. I'm having 12 volt batteries in 4 numbers, but I need 48 volt. So what can I do? I can add these batteries like series connections. I obtain 48 volt. Now we can understand the things. Suppose in any small two wheelers I want to run, I need 4 lead acid batteries. So what is the AH rating? 24 AH. So I can add these 4 batteries in series connection. I can obtain 48 over AH. You can easily understand the things. So what is the weight of that battery? I am using 12 volt 24 Ah. The weight of the battery is 7 kg. Now come to the picture. You see how many batteries we are using? 4 batteries. So 28 kg. So please understand what is the drawback of the lead acid battery. One is duty cycle is very low, like 600 cycles are obtained the maximum level. Then second one is the battery weight is very high. In this normal two wheeler, the battery weight is nearly it is 28 kg, means it is nearly half of the person. Am I correct? Suppose we are using two wheeler, 2% is the maximum capacity, but the battery itself, it is occupying half of the person weight. So that's why last 10 decades EV is not famous. We want to get the remedy from this one is called lithium ion chemistry batteries. So it is called LiBs batteries. What is the main advantage of the lithium ion battery is high energy density. So that is the main advantages of the lithium ion battery. Uh, then these lithium ion batteries are several number of chemistries are available, but what we are using in the laptop and the electrical bikes, lithium ion is one of the thing. Generally in market, lot of companies are they are giving batteries cells. One of the company is called BAK. The operating voltage is 3.7 volt, 2200 milliAh. The type of the battery is called 18650. These cells are used in the electrical vehicle. Dear participants, you want to keep it in your mind. While you are going to choose the lithium ion or lithium chemistry batteries, various types of operating voltage and various types of capacities are available. So each and every capacity has having some serial number. So mostly in electrical vehicles, we are using lithium ion battery. That lithium ion battery's operating voltage is 3.7. The AH value will be depends upon the company to company, but the cells we are used in EV is called 18650 in lithium ion. So lithium battery is having several number of chemistry. So by adding some other elements, it will having some separate characters. So that and all you can go through by Google. We can obtain several kind of battery chemistries are available in lithium based. So mainly currently we are using two kind of battery. One is called LFP, another one is called NMC. NMC is called our lithium nickel based batteries. Then now the trending battery is called lithium ferrophosphate. It is called LFP technology. So I already you see this picture in NMC. The operating voltage is here. I think we want to change this, right? Yeah, you see, this is called lithium ion cell. The operating voltage is 3.7. The capacity is 2200 mAh. This is called lithium ion. Then top side we are using one battery that is called lithium ferrophosphate. That lithium ferrophosphate battery having 3.2 volt, but the AH value is nearly 6 AH. So what is the advantage of the system? In lithium ion normal cells type, we are using the capacity is 3.7 volt. 3.7 volt. The ampere hour is only 2200 mAh. But in lithium ferrophosphate, we having 3.2 operating voltage. Then 6 AH, that means 6000 mAh. So that is the main advantage of lithium ferrophosphate. Then according to operation wise, in lithium ion is having high energy density, then compared to lithium ferrophosphate. Then according to safety aspect, lithium ferrophosphate is having more than 30-degree temperature withstand compared to lithium ion. So in lithium ion and lithium ferrophosphates are mostly used in the electrical vehicles nowadays. It having huge demand of in India market because of mostly all the people they are trying to switch over to electrical vehicle. So that is now lithium ion cells are very demand in India. Little bit they are rising the cell cost also. You consider this cell, it having several number of times. I will explain later. But normally in grade 1 batteries, the one single battery cost is single cell cost is around 300 in A grade. Then B grade it is nearly 140 rupees. Similarly, you can consider the lithium ferrophosphate. Now it is available in single piece. The cost is nearly 175 rupees per piece. The title is what is the future of the EV. So in Indian market scenario, it is based on the US market. So this is the standards for million dollars things. You see the scenario of the lithium battery market in India. So previously the lithium ion cost is very high. The people they are using only the lithium ion cells in laptops and other medical applications only. But due to the EV market entry into the ground, the prices are now reduced. Similarly, simultaneously, the demand of the lithium ion batteries also, you see this picture, you can easily understand it is gradually, it will give huge demand in our Indian market. You can easily understand the thing where we are in 2021. The requirement is high. In 2020 24, $5,022 million requirements are there in our India itself. I am saying about only in two-wheelers. I am not calculate about the buses and other things. Please understand the things. What is the need of the lithium ion cells in market? Before in 2024, they may be introducing lithium ion or supercapacitors as a fuel for electrical vehicle. The demand will be reduced. But initially, the cost of the fuel cell or supercapacitor is high. That's why the people they are now currently using lithium ion batteries. You see the year-wise comparison, the battery price. Startingly, the cost is nearly 1060. Now it is reduced in 2018. It is 176. Now it is 2021. The cost is around 110 or 120 rupees. So in future, the cell cost may be reduced. The main drawback of the system is the raw material which is used in the lithium-ion battery is not available in India. We are fully depends upon the foreign countries like China and other countries, Taiwan and other countries. But mostly we are depends upon the Chinese batteries. The factors of lithium ions is why they are people they are replacing the in lead acid battery, then they are choosing lithium ion batteries. These factors is the main important. First one is called the price. It is in 1 or 2 years the price may be equal of lead acid battery lithium. Now slightly it is high. Comparatively, I am saying the example. I am going to purchase the 12 volt 24 Ah battery in lithium. Sorry, in lead acid, the cost may be around 3,500 means. Now the lithium ion battery, the same capacity is 5,000. So 1,200 is the variations will be there current scenario. Within a decade or within a 5 years, it may be equal. So once it is come equal means mostly all the people they are neglecting the lead acid battery. They are switched over to lithium ion batteries. One more important parameter is like solar power. So people's those who are using solar based power in home or industrial applications, during the night time they want to operate the electricity, they are implement the storage devices lead acid batteries. Now the trend is entirely changed. You know, once the people they want to buy a new UPS, the people they want to go to the electrical shop, they asking one UPS, then they asking one battery. But uh, we are using in lithium ion batteries. It's very compact size and the energy density also very high. The cabin itself, like inverter, its side inbuilt batteries are available. Just they are plugged in the wall. It is enough. No need to monitor the batteries. Like we want to add the water and other things, it's not necessary. So purely maintenance free battery and inbuilt with the inverter itself. So this is the main advantage. Now you are going to purchase in solar based inverters. The single cabinet itself, inverter and battery, everything is are inbuilt in the single unit. It is just wall mounted. You can go for the applications. Then according to the C rating of the batteries, generally C rating is very important by choosing the batteries. Normally in electrical applications like EV, two-wheelers, we are using 3C cells. Participants, please, we are going to design the battery for electrical vehicles. We are using 3C cells. Suppose I am going to use for solar applications, 1C cells are used. So in electrical lithium ion batteries are transferred into two kind of things. One is application wise 3C rating is used for electrical vehicle and 1C ratings are used for solar vehicles. Then second important parameter, energy density is very high. Then third one is discharge ratio is like C rating is more capable compared with lead acid. Then fourth important parameter is compared to lead acid battery, lithium ion battery capacity is very high. Why? Sorry, duty cycle is very high. I already told what is duty cycle. So duty cycle is nothing but one charge and fully charge and one discharge. It is called one duty cycle. The minimum duty cycle of the lithium ion is called 1,200, but minimum guarantee is 1,000 cycles. It is available up to 5,000 cycles. Duty cycles are available in the battery, but the minimum duty cycle of the battery is 1,000 cycles. So what is the advantage of lithium compared to lead acid? In lead acid only having 600 duty cycles, but in lithium 1000 duty cycle. So that's why the people they are going to switch over to lithium based batteries. Then second advantage is the battery weight is one third only. Suppose 27 kg means it is having only 7 kg. So automatically the vehicle weight will be reduced means it will give more mileage. So that is the beauty of lithium ion cell. Then another one is important parameter, the capacity of the battery. So previously I told how many batteries we want to use for lead acid battery for 48 volt system. We want to connect 4 batteries in series manner. But hello, sorry, am I audible?
Yes, sir. I'm just telling the answer.
Yeah, you're giving the answer. Okay, correct. Okay, good. Actually, we want to use 4 batteries, but here we can design 48 volt, 60 volt, 72 volt, even we can use design for 110 volt. It depends upon the compared to lead acid. So these are the factors the people they have switched over to lead acid to lithium ion batteries. So then next one, this is a little bit comparison about the lithium ferrophosphate and lithium ion cells. So already I told the specific energy density is called capacity of the discharge capacity of the then Sir, can you hear my voice?
Sorry, voice is audible.
Oh, sorry, sorry,
Share
sir.
the
Some bandwidth issues happen. I want to share my slide. Sir, my slide is visible for you, sir?
Sir.
Sir, it is visible?
Yes, sir, it is visible.
Okay, thank you, sir. Thank you very much. Okay, sir, this is about the types of cells. One is called pouch cell, another one is called cylindrical cell, another one is called prismatic cells. These cylindrical and prismatic cells are used in the EV applications. Mostly in companies side, maximum current rating discharge, they are using prismatic cells. And normal applications like the capacity of 2 kilowatt batteries, they are using cylindrical cells more than 2 kilowatts. Otherwise, the amps rating more than 100 amps, they are using prismatic cells. So this is the types of cells. Then coming to the concept, you know very well about the cell rating. The cell rating maybe we can consider 3.7 volt. We want to obtain 12 volt means we want to connect seriously. It is obtained 12 volt. Okay, the AH is the important parameter. Please understand the things. I am using single cell. The capacity is 3.7, 2200 mAh. That means 2.2 mAh. You see the first picture. I am having 4 batteries connected in series. So how many voltage I can obtain? 4 into 3.7. Am I correct? Audience, please.
14.8.
The cell capacity is 3.7 volt. The capacity is 2.2 Ah. So I connected 4 batteries. So how many will come? 4 into 3.7. So 14.8 will come. Am I correct? Yeah. Okay. What is the capacity of the battery? 4 batteries. The voltage is 14.8, but the capacity of the cell is 14.8, 2.2 Ah. Please understand the things. Is it clear? So battery is mentioned by AH only. We are having 4 batteries. So operating voltage is 3.7, 3.7, 3.7. It will come 14.8. But capacity of the current value is 2.2 AH only. But the customer is asking, sir, I need 14.8 volt, 4.4 AH. What we can do? We can choose 8 batteries. First 4 batteries are connected in series, another 4 batteries are connected in series. Then these two are connected in parallel. So what is in by series and parallel? N-to-N connection is called series. Positive to positive, negative to negative is called parallel. So I want to increase the current value. That means AH value means I add the number of cells in parallel. I want to add the voltage means I can add the batteries in series. So this is the very basic fundamental of the battery technology. So you know very well. For example, I am connecting 4 battery means it is called 14.8 volt. It is used for 12 volt applications. Okay, but I connect several number of cells in series and parallel. I can design the battery. But what are the problems I am going to face? First one, I connect the charger to the batteries. Once it is fully charged, but even though the flow occur in the battery, the over voltage will come, it will damage the battery. Then second one, I drain the battery using some applications like EV applications. It is fully drained. So the battery not able to charge once again. Then second one, unknownly or accident happen means short circuit will happen. Short circuit will happen means automatically the battery will burn. Then next one, even though they are purchasing the same company cells, but they're having some chemistry changes, the voltage level will be changed. So for we want to maintain all the cells voltages are common. For that purpose only we are using cell balancing things. Then thermal production. We are using electrical bike in continuous manner or 3 hours or 4 hours. Continuously drain the current. It will produce the more heat. That's why it will extend more than 60-degree temperature. We want to protect the battery. So these are the drawbacks we are achieved in the battery pack. So what we want to do? We want to rectify all these problems. What are the problems we are facing? Audience, please. Any one of the guys, please reply. Give the reply.
Over voltage production, under voltage
Yeah,
production, short
over
circuit
voltage
production.
production is very, very important. The next one, under voltage production is very, very important. Then second one, third one.
Short circuit production.
Any vibration or mechanical fault or accident happen means maybe a chance to short circuit. So once the plus and minus is short circuit means it will burn. It will emit more huge amount of heat. So that's why we want to protect that short circuit. Then another one important parameter is called balancing voltage. It is cell chemistry is same, but the voltage capacity may be slightly changed. We want to rectify the things. Then suppose continuous run, heat will be produced. We want to produce more than 60-degree. We want to cut out. All the things are monitored and controlled by BMS. Please, my dear students, sorry, I am using the word students. Sorry, dear participants, BMS is the very, very important parameter while you are going to design the lithium-ion battery. So in lithium-ion battery, what is the use of BMS? BMS is nothing but battery management system. It is made by purely electronics component and sensors. So what are the electronics components used in this system is called, one is called MOSFET. You are already studied the basic things in 12th level. You can study these transistors, SR, MOSFETs. These elements are act as a switch. Then some sensors like current, what is the current rating we want to monitor, we are using current sensors. Similarly, last point is called thermal production. We want to use thermistor. Now, thermistor is one kind of sensor which is used to sense the minus and plus degree Celsius in the battery pack. So, what is the use of this battery management system? Battery management system is it is to give the production circuit to the battery. One is called over voltage production, under voltage production, short circuit production, cell balancing voltage, and thermal production. I want to mention one thing about the cell balancing system. Cell balancing system is nothing but group of cells we are using in this system. Am I correct? You see this picture, we are using several number of cells. It's connected in series and parallel. But I connect to the charger. First cell is having high voltage. Suppose I give 5 volt. It will first cell is having 5, but 4.9 and 4.7 it will obtain. So charging voltage will be different means different kind of charging capacity of the cells are available in the group. But what is my application? The voltage of the each cells should be common. So for that purpose, electronically we want to design some microcontrollers inside the BMS. What is the role of that microcontroller? Each and every cells they are using one pull-up resistance. So what is the resistance? What is the use of resistance? You know very well. Resistance is opposed the current flow. So that resistance are connected in each cell groups. Whenever the compare two cells, one cell is having 3.8 volt, another cell having 3.6 volt, mean which cell having 3.8 volt, just that they connect the resistance across the plus minus, they discharge the voltage. Discharge the energy, once it will discharge means automatically it become 3.7. Similarly, that excess voltage is drained by the resistance. That is called active balanced method. Then passive balanced method is called two type of balancing systems are used in the BMS. One is called active, another is passive. The passive system is what they are using. If we found 4 group of cells, one group that group voltage is, we are using pull-up resistance, energy is wasted. So in cell balancing system is classified into 2 categories. One is called active, another is called passive systems. So once you can connect the series and parallel connections, then you are implement on BMS system. Then after that, the battery pack will come for ready to delivery. That is the basic system. This is one of the battery. The capacity is 48 volt 24 Ah battery. So this is the cells what we are using in the our product. Normally it is called PAK system. PAK is one of the company make. I already told we are using BMS. So this is the electronic circuit. Sorry, it is visible for you, sir. Can you hear me? Okay, thank you, sir. Thank you. I already told how to assemble the batteries. Then I am going to explain about the BMS also. You know very well what is the role of BMS. Over voltage discharging, all the monitoring control made by the BMS. You see, this is P minus and B minus. So please, you can understand the things. P minus is nothing but this is the output wire of the minus wire. Battery having two wires. So P minus is nothing but power output line. So you can understand in BMS system only connected in the negative lines. They are not using the positive wires in the BMS. BMS only used in the negative lines parameters. So this P is used for power output wire minus wire. Similarly, you see this P minus is given to the battery cell voltage. This is one parameter. The next one, these wires, please understand, these wires, it start from black, then remains are red color wire. So what is the use of these wires? So this is called serial monitoring system. Suppose I told 4 batteries are connected in series. Am I correct? Previously, no one will give the answer. Huh? Yes or not?
Yes, sir.
Hello.
Yes.
Am I audible? Yeah.
Yes, sir.
Now
Yes,
I am give the assignment to you. I connected 30 cells in series. How many voltage it will obtain? Single voltage is 3.7. Okay. I connect 13 cells in series manner. What is the output voltage?
48.1.
Yeah, very good. The answer is visible in your slide itself. Am I correct? You see this picture, you can easily understand.
Yes, yes.
So what is
45,
called
48 volt.
48.1? Am I correct?
Yes, 48.1. But lithium here
Yeah.
48 volt.
You see this one. Now you can easily understand the things. Lithium ion battery. What is meant by 13 years in this picture? What is indicated 13 years? Here I put 13 years. No. What is the use of this one? That means
cells.
13 cells are connected in series. That is called 13S. Suppose I put P means number of cells connected in parallel. So what is the use of parallel? I want to increase the AH value. Current value increase, we want to increase means I want to add in parallel. So when you are going to purchase the battery or going to assemble the battery, we want to purchase the number of group of cells. It may be connected in series and parallel. After that, we want to buy the BMS. It is readily available in the market. Otherwise, you are the basically electrical electronics people means you can made using microcontroller and the other MOSFET switches. You can design. You see here on black color wire is there no in bottom side. That is called a thermistor. So this thermistor is used to measure the temperature of the battery pack. So we connect the series and parallel. Then you insert this black color wire into the cells. It will read the temperature from the cell. It is given to the BMS. So once it is exceeding the 60 degree Celsius in the battery pack, automatically it will turn off the battery output via using this BMS circuit. Then what is this? These black color and red color wires. Please understand, this black color wire is given for the battery first minus point. So you are connecting these batteries in series and parallel. No, you see this slide. In this slide, where you see the first series connection, where is the first minus is start? I think here. My cursor is visible for you. Cursor movement.
Yeah, visible.
Yeah. In BMS, you see this diagram, please understand. In this BMS, this is the minus point. So I want to connect this black color wire here because this is the 0 point. I want to connect the black color wire here. Then after that, the next red wire is connected here. The next red wire is connected here. The next red wire is connected here. That next one, black color is, sorry, red color is connected here. What is the use of this wire means? It is monitored by the individual group of cells. You see this picture. I connect the black wire here, then red wire here, this red wire here. It is used to monitor the particular group of cells. Now you can see this picture. You can easily understand the basic of the things. You see this black color wire. Where I want to connect this black color wire? Please anyone give the reply. Here you see in several number of, yeah, this first black color is given to the series group minus. Is it clear?
Yes, sir.
You can count here 13 red color wires are there. Each 13 wires are connected here. Where we want to connect means each and every. So here I use the 0 pin, that is black color. After that I am using red wire here, and here. Likewise, 13 red wires are used to monitor the individual cell group. So that is the main advantages of the BMS. Even any one of the group got failure, it will trip the voltage. So now you can understand the important parameter of the BMS. So what is the use of BMS? You know very well after complete this session. So this is the basic. You see already I convey the things. Here I want to connect this black wire here. Then each and every red wires are connected here. It will give 48 volt 13S series. One more thing, I want to connect the series. I am not using soldering wires to solder the batteries. Please, participants, please understand. You are going to purchase the cells. After that, you want to connect in series. You don't want to use soldering wires and other things. Better, you want to use welding mechanism that is called spot welding machine. So, use it having two terminals. These two terminals, you using some nickel strip. You see the picture. We want to arrange all the cells likewise. Then after that, we want to using nickel. You see the silver color is called nickel strip. These nickel strips are connected here by using spot welding machine. You see his hand, he using some two pins are there. Just they are making the soft circuit. Automatically it will melt. It will join the battery cell and plate. So why we are using this type of means this nickel strip never corrode. While you are choosing the battery pack, corrosion should not take place. That's why don't use soldering components. We want to use welding based joining system using nickel strip. What is the advantage of nickel strip? Nickel having good conducting media, as well as it will not corrode due to the atmospheric conditions. So that's why the battery pack they are using nickel strips. So this is the basic way to assemble the batteries. First we want to assemble the batteries. Bottom side we are using cell holders. That black color is called cell holders. So I want to assemble the cells in series and parallel manner first. Then second one, I want to welding all the cells like this is the welding process. After that, I want to connect. You see this picture. This is the bottom side. This is the BMS board. This BMS board, I want to connect all the cells. I want to give all the wires. After that, using PVC insulation material, using heater element, I want to pack the cell. So this is the way we want to assemble the batteries. In our concerns also, we are assembling various kind of batteries. Like it start from 6 volt to up to 72 volt, 100 amps capacity. We are designing the batteries. So this is the process what we are using in our concern. This is the kind of we want to assemble the batteries. Then using spot welding machine, we want to assemble. Then we want to place the BMS here. Then after that, each and every series connection, we want to connect the wires. After that, You want to check the voltage level whether it is correct or not using multimeter. You can check the voltage. After that, you can pack the battery. So this is the fundamental things. So this is our model. We are making two-wheelers, especially for in cycle. This is the battery system. It is the capacity is 36 volt, 250 watts capacity battery. It will give 40 kilometer mileage. So due to time fact, I could not able to explain the operations of the thing, how it is operated. The next one. So this is the way we want to connect the motors and other things. This is the driver circuit, how the speed is obtained. This is one of the basic motor. It is used in the two-wheeler applications. Dear participation, shall we extend 5 more minutes with your permission? Okay, thank you. So my slide is visible for you, sir. Okay. Coming to the concept of lithium ion batteries, it is having several number of batteries are available in the market. The minimum we want to choose the cells, number of cells, you know very well, I already explained. Number of cells connected in series and parallel, we can get the output various type of. In lithium ion cells, the operating voltage is 3.7. In lithium ferrophosphate, operating voltage is 3.2 volt. So this is the dimension of the battery. So in trending technology, these are the A-grade cells available in the market. Once you are going to design the battery, these are the cells called high performance cells. What is available in the market? Then this is the operating chemistry voltage and capacity of the individual things. This is the application of EV cells. It is mainly used in the electrical vehicles, laptops, smartphones. Then a lot of applications, mainly it is used in medical applications. Why it is very important in medical applications? Suppose you are using ECG machine or cardiogram, or you want to monitor in the important technical parameter, the voltage fluctuations will come, means BMS will monitoring all the parameters, it will give the constant output voltage to the system. There is no error will occur while you are plotting the graph. So please understand the things. While you are plotting the graph like ECG, the peak value is slightly increasing, means the person do not having the heart attack, but due to the system failure, it will the peak increasing, means it may be wrong. So that's why in medical applications mostly they are using lithium ion based BMS based batteries. It is very important thing. Then drone is a trending technology. Are used. This is the internal components used in the lithium ion cells. So due to time fact, I passed the things. This is the characteristics of each and individual brand cells, like discharging current capacity and duty cycles. So this is the dimensions. Up to the level we are using the fully charged, the battery voltage is 3.7, but the fully voltage it will obtain 4.2 volt. Then we can discharge up to 3.2 volt. So this is the good condition battery. Once the 3.7 volt battery you are connecting the charger, we can obtain fully charge is 4.2. Then we can discharge a level. We can discharge up to 0, but the advisor level is only 3.2 volt. So these are the safety precautions we want to follow. Suppose you are going to
design the cells. This is the chart. The company they are asking these are what is your requirement, ampere, voltage, cell capacity, charging time, all the things they are asking. After that only they are giving the battery pack to you. So these parameters we want to monitor: cell choice factors, BMS, how many which voltage you want to cut out, which voltage you want to over voltage you want to turn out, which temperature. In our standard we are using 60° is the standard temperature we want to cut out the battery. So this is the battery management system. I give the basic example of this. Is already I explained about the things. This is the called 4S series BMS. In 4S BMS, you want to go to asking the soft. You just give I need 4S BMS for 20 amps. It depends upon the load. What is you are going to use? You can ask the battery BMS. You see in 4S having 5 terminals. First one is called connected 0. Then remaining 4 terminals are connected in the next lines. So this is the battery pack for 24 volt. You see here I'm using several number of batteries are series connected through this plate. After that I connect the wires like this. So before going to buy the BMS, you ask all the parameters to the company concerns. I need the charging voltage is 15, maximum discharge current is 20 amps. Likewise, you can give all the parameters to the company. They are decide the BMS. So dear participants, BMS depends upon in our hand. While you are you are the battery designer, you want to give the specification to the BMS company. So this is the current voltage, this is the voltage required, this is the current continuous current required, this is the temperature. Okay, if he is here in the 9th point, we are using NTC sensor. This is called thermistor. The temperature cut out in the discharging time 65°, charging time 50°. So these are the conditions I given to my BMS maker. They are make the product. After that they are giving the test. The test pass means they are giving the result, the tester. So after this all the fundamental process over, they are deliver the BMS pack to the battery company. So these are the variety of BMSs are there. Depends upon the things. Then this is the cell holder, how we want to sell the batteries. So this is the method we want to assemble the things using spot welding. We are assembling these batteries. You see this. After that you want to pack all the batteries in insulating method. This is the thermal production insulating coating. Then after that, this is called prismatic cell. So what is the advantage of the prismatic cell? The advantage of the prismatic cell is current rating is very high. Previously we are using cylindrical cell, but these prismatic cells, the operating voltage is 3.2 volt, but the current rating is nearly, it is available start from 20 amps to 100 amps, 200 amps capacity also available. So it is very easy to assemble the cells. So likewise, this is one vehicle. It is called hybrid vehicle. It is called hybrid vehicle. So for hybrid vehicles, this is called hub motor. You see this picture. This is the wheel itself. The motor is placed. Then this is the chain bracket. It is run by both petrol as well as battery. Initially, I want to run the vehicle using this hub motor. It will act as a motor. It will run the battery. Once the battery is drained, automatically I want to switch on my fuel system using this chain drive. Previously motor is there, it will rotate. So this is called hybrid motor. It is not normally, it is called hybrid system. Then I want to assemble the cells. In market itself, cell holders are available. So likewise, we want to assemble the cells. Before that, I want to check whether my cell having the capacity. I purchased the cell. The cell voltage is 3.7 2.2 AH. Whether their company are giving correct or not, we want to check the cells in some testing method. You see this picture. This is called cell capacity tester. Using this cell capacity tester, I connect this battery according to terminals. Then I on the device. Automatically it will discharge the battery by using this resistance. Then it will give final result how much capacity of the AH will remain in the battery. So this is the fundamental things. First we want to test the battery using cell capacity meter. So this is the basic things. Around the 24 rupees will come. We can check your cell capacity using single cells. So this is another method. This is used for 3 cells. Then similarly charging, cell chargers are available. Depends upon the charging size, we can adjust this plate. The next one, a lithium cell charger. I am telling about within 24 rupees you can, and it is available in the market. Using this lithium ion cell, I can charge the voltage, because while you are connecting all the battery pack, all the voltage should be same. Suppose some of the cells are below a voltage of the cells, we want to charge the cells before connecting in the battery pack. The next one, the same company having different type of chemistry. Suppose some chemistry is not matching, means it will give the lower performance. So once you are buying a group of cells, the group of container cells, maybe it is lithium ion means 100 cells will come. Otherwise you can use the lithium ferrophos means 25 cells will come. Suppose in any one of the group you can choose one cell. It is connected to the cell tester. Automatically it will give the reading of the voltage as well as how much of the resistance, internal resistance are present in the circuit. So why I am telling this means, just you can connect the battery, it is not performed. So we want to find out the internal resistance of the all the cells. It would be same. It is give the better result. So these are the measuring voltage it will give. Then similarly you can just digital displays also available. You can just connect this cell capacity meter. You can easily understand what are the remaining capacity of the AH value is there, what is the operating voltage will be there, all the things it will display. Suppose the next thing, sir, is visible for you, sir, please? I occupy only 3 more minutes. Sorry for inconvenience space. Once your battery package is ready, you cannot able to use in your vehicle. Please, participants, please understand. Once the battery package is ready, you could not able to just put it in your vehicle. You can run. It is not good, because we want to follow some rules and regulations which is implemented in our Indian country. It is called electrical vehicle testing certifications. Once you are the company manufacturer, you want to get the certifications, then only you can use your cells in the EV cells. So due to time fact, I rush up the things. So first one, the components layout is very important. Then safety precautions are very important. Please understand. Once you are going to assemble any electronics components inner side or battery, suppose you are going to design these ultra capacitor or supercapacitor batteries in future, you can't directly use in your vehicles. Before that you want to going to give the test your batteries to our government authority companies. Please, first three kind of companies are available. It is purely run by government. It is autonomous body. Nobody will control. It is not come under government control like our election commission. So first one is called ICAT. It is shortly called ICAT, International Center for Automotive Technology. You can you go through this website. You can get all the details. First one, ICAT. It is one of the organization. You want to give your samples, they will give the test result. Then one more company, it is called RI, Automotive Research Association of India. RI is one of the concern. You want to give your test sample to them, they will they will give the result. That the result satisfies means they will give the certification to you. Then you can go for your production. Then similarly in Tamil Nadu, Chennai itself, one government sector is there, that is called the Global Automotive Research Center. So you can test your product here itself. You can get the result. This is one of the companies. So totally 3 kind of companies are there. One is called ICAT, another one is called RI, another one is called Global Automotive Research Centers. Then quickly we want to you want to follow all the satisfaction, whether the connector is correct,
then rainwater capacity is there, then crush voltage is there. Similarly, we want to find out all the test. For example, BMS. I already told external short circuit, over voltage, temperature, all the tests they are carried out. This is the pouch cells. We want to follow the AIS 048 standards for lithium ion cells. At least we having three kind of tests called the mechanical and thermal and electrical test for the batteries, but at least we want to follow the green mentioned color test, then only they are giving the certificates to us. So in battery also it is we want to follow AIS 040. Please google it. You can read about the things. AIS 04 short circuit, over voltage, under vibration test, all the things we want to pass, then only you can get the certificate. So even vehicle also they want to follow the same regulations. Then finally, it is very important now in India having big opportunity for to implement in the retrofitting regulations. So retrofitting regulations means nothing but already 15 years old existing vehicles we can't go to scrap market. Just we can modify the vehicles once again. It is occupy the road line using electrical vehicles. That is called retrofit. Retrofit means nothing but already the existing fuel engine vehicles are converted into electrical vehicle. We want to follow the some regulations. It is mentioned by Indian government authority that rules we want to follow. Just Google it in AIS 123. You can get the details. You want to retrofit your vehicle, you want to follow these rules, then you can get the certificate, you can run in the road line. So this is about the EV sectors. Then on our central government, they are launching FAME 2. Once the entrepreneur, they are start their vehicles in our India itself, 75% of the components used in electrical, used in inner product like in Indian make. Then 25 from you can import from other countries. They will give the subsidy to the company. So lot of subsidies are available while you are going to design the battery pack as well as the two-wheeler sectors. It is come under FAME 2. In Tamil Nadu, I think Ampere, Okinawa, these two companies are already obtained the, it is come under FAME 2 applications. So this is about the EVR sectors. So what I am going to conclude the things, day by day the huge demand of the batteries or battery demand is very high. So depends upon the demand. The technology also the technology also slightly changing. So currently they are using lithium ion batteries for EV applications, but in future maybe the battery technology may be changed, means the peoples they may be go for aluminum air batteries or supercapacitors or ultra capacitors. Like this, lot of technologies are currently under research. Even in IIT Chennai, the students they are using several kind of research in the battery field. Finally, I want to give the final conclusion about this one. In future, our government aim is at least 40 to 50% within a decade or 5 years. We want to switch over to EV. That is the main expectations. By 2025, the road line we can see at least 50% of the electrical vehicles will be there. The huge demand of the batteries is sectors are there. In battery sectors now, I want to forget to tell about the things IoT. Now you can hear about the Ola company. They are launching one vehicle that vehicle is it is called IoT technology. In BMS, we already studied the BMS. Then BMS itself, we are having communication port like Wi-Fi and Bluetooth. All the things are inbuilt in the BMS. That BMS is connected to Bluetooth or Wi-Fi automatically. All the data, what are the voltage, what is the current, what is the capacity, all the data is connected through this Bluetooth to mobile or Wi-Fi to IoT technology. Then the customers and consumers and the company, all the person, they can see your vehicle parameters through your mobile. Once the battery is going to dead or drain,
duty cycle is suppose 1000 means it is nearly it is 900 cycles are over automatically by using that SMS system. The company they are giving the notification to through your mobile. Please going to change your battery. It is going to dead. Within 3 months or within 1 month they will give the notification. That much of technologies are now implemented in the electrical vehicles. This is the work we are going to implement in our system. We are changing this auto auto fuel engine into electrical vehicle. We are designing the battery. You see here we are placing this battery. This is the motor. This is the battery. If it is for auto cycles, auto vehicle, this is the display what we are using in the system. And then similarly, now flexible solar panels are available in the market. So the people, they want to use the research purpose. They can design the electrical vehicles according to their applications. They can, you see this picture, this is called flexible solar panels. They are using BLDC motors. The vehicles, you see this upper side, they are using solar panels. These solar panel outputs are connected through this lithium ion battery. It is charged, then they can use the vehicles. So this is one of the thing. The next one is called hybrid motors. The vehicle can run both the scooters or any kind of vehicles. The vehicles can run by as well as battery as well as in fuel system. This is called hybrid system. Hybrid system.
यहाँ पे एक्टिवा 5G यहाँ पे यूज करने वाले हैं, तो किस तरीके से करने वाले हैं वो मैं आपको बता
देता हूं.
this
is one of the
देख लीजिए, ये
method. You see already the petrol vehicles are there. So they are replacing this petrol engine. They are placing the motor. Now the motor can run both. You see this this type of vehicles, it is called hybrid. So the diesel engine as well as petrol engine, electrical motor and IC engines. Here in this dicky phase they are using batteries. So they are inserting the battery. Now we can run. It is as a hybrid, both motor as well as IC. So this is the trending applications as available in the market. So this is called a hybrid system. So these are the things. This is the maintenance purpose. I think this is not related to our subject. So I am going to conclude my session. Without the battery technology, we could not able to success in EV. So this is the right time, right scenario. We want to choose. Already we want to switch over to IC engine to EV. So in EV sector, battery is the main parameter. So that's why we want to do the research in the field of advanced batteries. So this is about my presentation. Thank you. If you have any doubt, you can ask. Otherwise, we can wind up. Sir, please. Perisami sir, I conclude my session. So I completed my session. Hello, am I audible, sir? Sorry, sir. Now only I am here. Please, once again, repeat me, sir. Okay. Sir, possibly you can read, sir. Sir, according to lithium-ion battery, it is more danger without using BMS. Please understand, because it is depends upon purely charger. What kind of charger we are going to use? For example, I'm designing the battery for 48 volt 24 Ah battery, the advisable charging current is 5 amps. But instead of 5 amp charger, I can charge, I choose 10 amp charger, we can quickly charge the battery. So suppose in the charger auto cutoff is not available, means it will overcharge, the battery get burned. So that's why we need BMS. BMS is monitoring all the things. Once the battery is charged, automatically it will disconnect the charger, whether the charger is connected to the battery, but it is not allow the current into the cells. So that's why without BMS, don't go for lithium batteries. Like it is a brain dead, means it will not give fulfill functions. So BMS is the main brain. So definitely without BMS we can't choose the battery pack.
Thank you for getting the answer. Any questions from participant?
Due to the time fact, I forgot to explain about the IoT system, because now all the battery packs are connected through IoT through BMS only. So if you are not familiar in BMS, just you can Google it. Bluetooth based BMS, automatically the options are available. You can just connect your device. That is also very easy one. It's not a complicated one. Sorry. Thank you, sir. So once again, I want to thank Mr. Sami sir for providing the opportunity me to share a few things about the lithium-ion cells in EV sector. Thank you very much, sir. Then I want to thank management also.
Hello, sir. Good afternoon, sir. Sir,
Good noon to all. I'm very happy to welcome our resource person for this session, Dr. R. Shivam Subramaniam sir. Obtained his PhD in electrochemistry from Indian Institute of Technology, Madras, and after he started his career in PSG Institute of Advanced Studies, Coimbatore, in electrochemical sensor and energy materials lab as assistant professor from 2015 onwards. His academic achievements are remarkable, such as overall proficiency award in MSc Chemistry, CLRI lectureship, and 254th All India rank in GATE exam in 2010. Further, he was awarded Best Faculty of the Award of Award for twice. He received a funded project from Department of Science and Technology (DST), UGC DAE, Consortium for Scientific Research worth of 3 crores. He has filed in patent with the DRDO, and besides, he organized many national workshops and presented invited talk in various institutions. And he completed 3 PhD students their students and their PhD under his supervision, and 4 more students from work under him at present. He also guided MSc and MTech students project work. He has published more than 50 international journals in his credits and authored and one edited book. With this brief instruction, I would like to invite Dr. Sivasubramaniam sir to deliver a keynote address on the materials for supercapacitor in the online forum. Sir, please.
Thank you for this nice introduction. Um, so I'll share my PPT now. Yeah, yeah. Is it visible, sir, to you? Yeah. So good afternoon and all. I thank the organizers, Dr. Periyasamy, for inviting me for this talk on the CSR sponsored seminar on the state of art future perspectives of hybrid supercapacitors for greener environment. And I also thank the management, Nehru Institute of Engineering Technology, for the invitation. So with this small introduction, I will just move on to the topic of today's talk. So today's talk will be completely on materials for supercapacitors applications. So what are the materials that can essentially be used for supercapacitors? Like what is the criteria that has to be fulfilled for a material that can be used for a supercapacitor applications? So all those things will be discussed here. So before going to the talk, I would just like to introduce my institute. Of course, many of you would have known since you are in around Coimbatore. So I work as an assistant professor in PhD Institute of Advanced Studies. It is basically a research institute of PSG where we draw funded projects and we develop labs for research facilities, and we work on several areas. So we have several characterization facilities like CM scanning electron microscopy, THRTM, and spray pyrolysis, thermal evaporator for device fabrications, and several more both morphological as well as spectroscopic characterizations. So I just listed a few in this slide. So I invite you all people to use the facilities for most of your research purposes. So basically, I established electrochemical sensors and energy materials laboratory in PSG. So I work mainly in 3 areas. One is on sensors, the other one is on supercapacitors and batteries. So in sensors, I work in the detection of neurotransmitters like dopamine and epinephrine, and also in the studies of bioelectrochemistry of NADH, and that is there in the bioenzyme in our human body. So those electron transfer kinetics on the electrode-electrolyte interface will be are being studied here. Our next one is on supercapacitors, where I mainly concentrate on the mixed metal oxide like spinel-based structures as well as biomass-derived carbon frameworks for the supercapacitor applications. And in the battery applications, I work on the development of anode materials for lithium-ion battery as well as in zinc nickel battery. It is a sponsored project by an industry in and around Coimbatore here for the development of zinc nickel battery. So I draw funds mainly from DST and the UGC for the fellowship as well as the purchase of consumables and equipments for my lab. So these are the main equipment which I have. One is a biologic. It is a multi-channel potentiostat, combined galvanostat. So at a time you can have some uh, 5 to 6 channels that can run experiments. Although we are attached with a battery tester, so we have separate fabrication facilities for both supercapacitors as well as lithium-ion batteries in our lab. Yes, sir. It's not moving. Just a minute, sir. Yeah, now did you get it, sir? Yeah. Okay. Okay. Thank you. Yeah. Right. So today's talk, the outline will be on uh, the present energy scenario that is there. We are seeing it on daily day-to-day activities, and the why we need actual and electrochemical energy storage systems. And I will throw some lights on the fundamentals of supercapacitors, through which I will make the criteria for how to design a material for a supercapacitor applications. And finally, I'll go a small shot with the device fabrication part. Right. So coming to the global energy scenario, you know that across the globe, only 10.4% of renewable energy is now being used for all the consumption purposes, and most of the energy sources are being drawn from the fossil fuels like coal, oil, and as well as the natural gases. And also, we know the consequences of these exploitations leading to the greenhouse effect. Thereby, you have a lot of changes in climate as well as other different problems we are facing in our day-to-day activities. So one such main problem is the pollution through vehicles, where we use the petrol or diesel extracted from the crude oil, where it use it for automobile purposes, polluting the environment to a very big extent. So in order to overcome all these problems, there was a focus on renewable energy sources like biomass, solar, geothermal, and hydro, as well as wind systems. And electrochemical energy systems comes under a different category. It does not comes under the renewable energies things, but they can be classified as clean energy sources, where we don't have any several other leading consequences like side reaction or emission of gases and all those stuffs. So actually, I can not you can actually categorize electrochemical energy systems as alternate energy sources compared to bringing it under the renewable energy category. So uh, these electrochemical energy systems can broadly classified into two different categories. One is on energy storage part, and other is on energy generation. So both batteries and supercapacitors, they belong to the energy storage application side, where you can generate energy and store it within themselves and use it whenever you need it. But when you come to the energy generation part, where the fuel cells and hydrogen generation through electrochemical water splitting, they all come under the energy generation part. That means where we can generate energy then and there and use it instantaneously, where there is no provision for storing any energy that is being generated. So these are the main categorization of energy electrochemical energy systems, and where presently the focus is on three main areas. One is on batteries, supercapacitors, and fuel cells. And you know that most of the electric vehicles that is being there in the market are all powered by lithium-ion batteries and fuel cells. Supercapacitors also hold a very important role in all these things. You can say that though supercapacitor cannot replace completely lithium-ion batteries, but they can act as an alternate or a supplement to the batteries which you use in the electric vehicles. So this is the famous Ragone plot, where you can see the supercapacitors are placed between the uh, capa- placed between the capacitors and batteries. So it is a plot between the energy density and power density of the system. So from this graph, you can understand that supercapacitors, they mostly have a higher power density and they have very low energy density. The batteries, on the other hand, they have very high energy density and they have very low power density in the system. So this is the main reason where batteries are being used for all our as a power sources in day-to-day activities. So supercapacitors, they cannot hold much energy for long air extents, but they can be used for many quick power applications as they have very high power density. So earlier, supercapacitors were used as a uh, power sources in flash cameras and UPS and CPU systems and all. But now we have a wide applications because the material chemistry has been improved a lot. So we find supercapacitor applications in several devices, starting from uh, as a toy, as a power source in toy cars, to remote controls, to solar watches, as a flash systems in cameras, and so on. And of course, we also see some bulk applications uh, where more 2 or 3 supercapacitor they get stacked, so that we can have a very high voltage as well as the high energy, or we can extract high power density to the systems. So sometimes supercapacitor as a single entity was also used in powering several devices. You can see the figure that is given here, where a forklift device was exclusively powered by a supercapacitor fitted system as a power source. So this because of this application, supercapacitors has gained very vast importance in recent days. Sir, is my slides moving? Were you able to see any problem with it?
Excuse me, sir. Your slides are
Yes,
not moving. It's in the
got
outline
it.
slide.
Still it is there now.
No,
I
it's
think
not.
it's
Sami.
now. Is it okay, sir?
Yeah, yes, sir, it is now okay.
Okay. So maybe there is some problem in the slideshow system, so I'll just directly keep it like this. Okay, so coming to the um, fundamentals of supercapacitors, I'm not going to go much deep into it. Just I will show some little informations on what is basically a supercapacitor device. So supercapacitors, you know that it is a basically a charge storage devices, right? So it helps to generate as well as store charge within the system. So you have best, depending upon the charge storage ability, they are divided into mainly on two different types. One is on EDLC, it's called electrochemical double layer capacitors, and other one is called pseudo capacitors, and the combination of both results in hybrid supercapacitors. So the basic principle between the EDLC and pseudo capacitors is EDLC is a non-Faraday kind of charge storage will be happening, and pseudocapacitors is the one where you see some Faraday charge storage. That means there is an electron transfer that occurs between the electrode and the electrolyte interfaces. So based on this charge storage, you can also classify the materials. So all the carbon systems, like what you see in graphene, carbon nanofibers, carbon nanotubes, activated carbons, and all those comes under the category of EDLC systems. And when you talk about supercapacitors, both we deal with the metal oxide as well as conducting polymers, where you see the electron transfer reaction that is taking place. So they all come under the pseudocapacitors category. The combination of both will result in a hybrid supercapacitors, where you can use it as a asymmetric system, or you can use it as a composite system, or in other words, nowadays there is a combination with the rechargeable battery type. They are called a supercapacity, where one electrode will be a supercapacitor material, another electrode will be a battery material. Okay, so these are the main material classification that are being used in the supercapacitors. And you know that the introduction of nano has explored, introduction of nanochemistry and nanotechnology has given a vast applications on several fields because of the low because of high surface area with low dimensions. So based on these nanomaterials, you can classify according to their structures with the 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional systems. So um, several systems like nano, we can prepare the material chemistry gives a very big provision, so that you can prepare the material of your choice according to your shape as well as your size. So we can prepare shapes of the narrow rods, nano wires, nano as well as several systems, nano structures, even fibers can also be printed on those systems, right? So this is, so all these materials, when they use this in a supercapacitor, the performance has been shown to be increased in a manifold way. It has increased in more than 2 or 3 orders of magnitude compared to what we see in the bulk system. So this is the basic mechanism. You have where you see the where all these Faraday and non-Faraday system as being represented in a graphical way. So the first one shows the charge storage which occurs through an non-Faraday system. That means it occurs only through an absorption of ions over the electrode electrolyte interface. So before going to this systems, you are supposed to know the electrical double layer. What happens near the electrode electrolyte systems? You have mostly you know that when you have a dielectric in the system, when you have two metal plates, there will be a charge separation between the dielectric medium. So the same concept also applies here. So when you have a metal electrode which is kept as an anode or cathode, you'll be having a separate charge. Suppose you take an negatively charged electrode, you'll be having a negative charge electrode over the surface of the metal electrode, so which will attract the positively charged ions which is being solvated with the electrolyte towards itself. So that forms a double layer within the electrode and electrolyte systems. And of course there are several classifications like inner Helmholtz plane, outer Helmholtz plane, and further if you move it forms a diffused layer. So the absorption of ion within the Helmholtz plane will generate a voltage, and that is being stored in as a charge in your device. So this is a completely arises through only the absorption of ions. So it is mostly classified as a non-Faraday type of supercapacitors. When you come to pseudocapacitors, you will see a Faradaic reaction that takes place. That means an electron transfer that occurs between the electrode as well as the electrolyte system. Of course, this electron transfer will not be as prominent as we see in other battery materials, that you can easily classify through the cyclic voltammetric studies, which I will be dealing it in the next slide. Right. So in order to classify a material to be a supercapacitors, we need to have three main characteristics. First thing, it should have a very good high surface area. And second one is it should have a very good porosity. And third one is it should have a very good kinetics of redox transition. That means electron shuffling should be very fast. So when you have a very high surface area and high porosity, it helps in absorption of electrolyte ions over the electrode surface, as well as the porosity will help you to penetrate the absorbed electrode ion deep inside the electrode material, so that the charge accumulation will also be very high, and the consequences of capacity will also be increased manifold. So these two category come to under the EDLC part of the material. Of course, if you have a pseudo capacitor, all these things has to be met. So it should have very high surface area, which have very good porosity, and it should have a very good high redox transition state. And of course, if you have a metal with different oxidation states, suppose you take ruthenium has a very good several oxidation state within itself. So this transition will also help to improve the capacitance of the material. So all the material has to be choose based on only these three criteria. Okay, I'll go with some fundamental electrochemical techniques through which you can classify the behavior of EDLC as well as pseudocapacitor material. So this is for every fundamental supercapacitor, the first thing that they will do is to check the cyclic voltammetric response. So for ideal supercapacitor, it has to give complete squares, complete rectangular shape that is shown in the red color in this figure. But of course, due to the experimental conditions and other things, you won't be having the same response what you see in ideal conditions. So when you take a EDLC kind of behavior, it shows a quasi rectangular shape that is being shown as a blue color graph here. So you can see a quasi rectangular shape for an EDLC behavior. Now when you come to the pseudo capacitor side, as I told you, it also has some electron transfer between the electrolyte interfaces, so the corresponding redox peak can be observed in the CV studies. So this redox peak should not be as prominent as we see in the batteries. So there should be only a very slight hump in the CV studies, which indicates that it should have a it is having an electron transfer behavior. So that is why the name has been given as a pseudo capacitor, so it's not as a real capacitor. So from this, you have to identify what kind of behavior the material shows, whether it is an EDLC or it is a pseudo capacitor. When you combine both, it has to have the characteristics of both EDLC as well as a pseudo capacitor device. So with this, you have to move to the next part where you can see the charge storage ability by passing some different current density to the system through a galvanostatic charge. That means you have to charge the electrode at a certain current density for a certain period, and again you have to discharge it to the same system. So this charge and discharge storage will help you to evaluate the accurate capacitance, specific capacitance of your material. So again, the both EDLC and pseudo capacitor can be differentiated from their response. So when you take a GCD response for a complete carbon material, you will be having a simple triangular shape. Simple triangular shape. So this red color shows the EDLC behavior of a GCD behavior of a EDLC material. So you'll have for a charge discharge, it will increase from certain potential to certain time. Again, it will discharge back from the higher potential to the lower potential. Now, when you come to the pseudo capacitor material, since as I told, it involves an electron transfer reaction, it won't be a complete triangular shape. It involves some electron transfer reaction, so it will show some hump, and there will also be seen some IR drop within the charge discharge curve. So this IR drop mainly arises when you construct. It depends upon the construction of the cell as well as the material that you coat on the electrode. And finally, people also carry out some impedance analysis to study the structural modifications after all these charge storage studies, whether there is any alteration in the conductivity of the material, on accurately give you how much performance the device can do. And when you come to the two electrode system, of course the capacitance will be drastically reduced since you are reducing the electrode systems. So of course this will reflect the further steps where you go for the device fabrication levels. So mostly these two electrode systems, they can be the arrangement of this fabrication like this. You can have a stainless steel plate followed by a current collector and an electrode. This can be either a negatively charged electrode. Then they are using a separator. Then you can have a positively charged electrode above that and a current collector as well as stainless steel. So you can completely seal the system without any interference from the environment. Right, separator, mostly it will be soaked in an electrolyte system. So electrolyte, you can have acid as well as base electrolyte. Sometimes you can use organic non-aqueous electrolyte also, depending upon the required condition. So this is how a simple supercapacitor fabrication has to take place for your material. Right. So now coming to the main part. So each material have their own properties and they will exhibit their own capacity behavior. So when you take the supercapacitors with EDLC behaviors, that means they shows charge through non-Faradic reactions. Mainly the carbon materials are being used was in exhaustively. So nowadays people are using graphene, CNTs and activated carbon as the base material. Why? Because their surface area is very high. If you take graphene, it has a very high surface area of around 2500 to 2500 meters square per gram. So this is very, very high. Theoretically, the value is like that, but when you come to practical side for preparing the material, it is very highly difficult to achieve the surface area to that extent. But of course, there are several research activities that still going on to improve the surface area of this material. So we have several methods, starting from Hammer's method to you can go to CVD deposition, where you can even have a thin film of graphene over the electrode surfaces and so on. And the other conventional study is through activated carbon. So activated carbon is the again big beneficial is that it has a large number of pores, both macro pores as well as micro pores in the system. And depending upon the synthesis condition that you do, you can manipulate the behavior of the system, behavior of the carbon system. That means you can control the size of the pores, as well as you can increase the surface areas, and also you have the provision to activate the material through certain means, right? So mostly when you go for a supercapacitors with a for both eco-friendly conditions, people go through activated carbon, where the most of the carbon they are derived from a biomass source. So biomass source, they will be treated with some high energy temperature conditions through furnace or something, then finally they will be activated through an alkali system, and from this can be used for your study purposes, which is the carbon that is produced is highly eco-friendly in nature, because you are generating the material from a waste. So that is a big advantages of this material, right? And coming to the pseudo-capacitors, so first metal oxides are being prominently used for all these studies. The the best material that still exists is the ruthenium dioxide. Ruthenium dioxide is a uh, we- ruthenium dioxide is a very best material which exhibits a theoretical capacitance around 1500 farad per gram. And here you can see that the CV response of ruthenium dioxide, it shows that it, of course, a quasi rectangular shape is there, but with a little hump on both the forward and the backward cycles, which indicates that a slight electron transfer has been taking place within the system, right? So depending upon the number of oxidation state or transition that is available in the metal, the capacitance again will have a manifold increase. So ruthenium has a very good transition state starting from +2 to +7. So this transition will impart in the capacitance of this material. Though ruthenium dioxide is the best material, but due to its expensive nature, it is not being used for commercial purposes. So there are several other alternate materials like manganese dioxide, cobalt dioxide, and iron oxide, which are now being prominently used. Of course, these are conventional methods which are used earlier. Now we have mixed metal oxides like spinel and perovskite structures, which are also presently being used for supercapacitor applications. And then coming to the conducting polymers, so not all polymers are conducting in nature. Only few have the ability to conduct or shuffle the electrons between the electrode interfaces. So there are several polymers in this category. So to list a few, the commonly used polymers are polyaniline, polypyrrole, polythiophene, etc., and so on. So again, this polyaniline, they also behave as a pseudo-capacitors, and the electron conduction through this polymer is little different when you compare to a metal oxide. So this conduction happens through the polarons and bipolarons formation within the polymer framework that is being extended throughout the carbon chain. So the performance of these conducting polymers depends upon the dopant system that we add while we prepare the material. So depending upon the type of dopant, whether it is a p-doped system or an n-doped system, the conducting behavior of the polymer will change. So when you have a polymer with a very good conducting capacity, it also acts as a very good supercapacitor behavior, right? So mostly preparation of these polymers will also very easy. You can go through both. You can use chemical method as well as electrochemical method. The advantage of electrochemical method is the deposition of the polymer over the electrode surfaces. So there is no, the process will be further simplified. So there won't be any electrode fabrication process and all, right? Coming to the next part, the perovskite based supercapacitor that I told earlier, where conventional metal oxides are now being transformed as a studies on the perovskite as well as spinel based mixed metal oxide. So when you have these kind of perovskite and spinel based systems, you have one or more transition metal ions in the systems, and also they have separate crystal lattice within the systems. When you take perovskite, mostly it will be a crystal lattice with some oxygen deficient sites within the systems, and this perovskite as well as the spinel based structures are also being used in supercapacitor applications now. When you come to perovskites, it is the charge storage mechanism is little different, where it is not like the conventional electron transfer reaction. It is occurs through an intercalation mechanism where we see in the lithium-ion batteries. Lithium-ion batteries is not an electron transfer. It's not a chemical reaction actually. It is a intercalation between of lithium-ion between the cathode and anode, right? So the same concept applies here, where the electrolyte ions, suppose you use a H plus ions, or if you use acid OH base ion, OH minus ion, they intercalate within the that means they go and sit in the interstitial sites of the these kind of peroxides, wherein a charge or voltage arises, and through which it can store capacitance. But the only problem with these perovskites widely is the stability of these materials. The stability of metal is a very big question. Of course, there are several other chemical synthesis method or strategies through which you can improve the stability of the material. So when you have a material with more oxygen deficient sites, you can also exhibit a very good capacitor material, because you have the provision to for the electrolyte ions to get intercalated at a very larger extent. So that is why the capacitance will also increase there. Right. So coming to the next part, as I told, when you want to have a supercapacitor with the eco-friendly nature or environmental friendly thing, you have to go for sources that is there in the our environment. So mostly if we generate it from the waste, so it is a very good added advantage for us. So biomass carbon atoms can be the sources are very high. You can even extract it from rice husk, even from banana strips, or so many things are there. So you can you can carbonize all those materials, because they are all mostly made up of cellulose. So when you carbonize the material at a higher temperatures, they all be converted to carbon, and this carbon can further be activated through some chemical processes. So those carbon behave in a very good as a material as a supercapacitors, right? So I have classified the number of material that is being reported with respect to the publications that has being done up to, this is up to say up to 2020. You can see that material with the carbon has been reported to a larger extent next to metal oxide and their composites. Composites nothing but what I'm talking is about the composite of an EDLC and a pseudo capacitor behavior. Now you can see that the conducting polymers and the metal oxide frameworks and zeolites are now slowly arising as a promising material for supercapacitor applications, and also material generated from waste. That was I'm talking about the biomass carbon is also being gaining increasing attention. So maybe in future you can have a commercial devices which is completely generated from a waste material. The material will be prepared from a waste source. Of course, you can see the importance of carbon material from the publication itself, and even in the commercial aspect also, the Maxwell supercapacitor, which is being available in the market with a voltage range of 2.85 volt. They're all mostly made up of this carbon source. Mostly a carbon, they are both electrode as well as the cathode as positively charged electrode as well as negatively charged electrode or carbon based material. It is being used, and of course we have the same supercapacitor with different higher end configurations, which can withstand more than 10,000 to 1 lakh stability cycles, and also have a capacitance around 3,500 farads. So these are the general things that is that we can talk about the materials for supercapacitor applications. Now, basically, in my lab, I mainly concentrate on spinel based materials. So spinels, you have different kind of things, normal spinel as well as inverse spinel structures. So what I did is I chose the normal spinel structures with 3D transition metals of nickel, manganese, and cobalt systems. So we concentrated mainly on nickel cobalt oxide as well as magnetic cobalt oxide. So we changed the chemistry during the preparation of the materials, and we studied their performance for supercapacitor applications. So the main choice of this nickel, cobalt, and manganese is because of their redox transition state. So when you take nickel, you have +2, +3 configurations. Cobalt is in higher end, like +3 and +4 oxidation states are there. Manganese can exhibit in +2 and +4 oxidation state. Right. So in the case of nickel cobalt oxide, what we did is we prepared the material through a normal hydrothermal techniques with some both nickel and cobalt precursors, and the only slight material synthesis, we changed a slight chemistry in the sense that we induced some um, secondary phases to the systems. That means we alternate the stoichiometry in such a way that along with nickel cobalt oxide, the nickel oxide precursor crystal phases are also present within the same crystal structures. So this can be done just by altering the stoichiometry during the synthesis process. So the material was accordingly classified or characterized using several techniques like what we see here with TGA, DSC, as well as the XRD system. So from XRD, we could confirm that nickel oxide secondary phases are being present in the crystal structures. Of course, they are again further in order to evaluate the surface area measurements. We carried out BET. So accordingly the surface area was found to be around 50 to 60 meters square per gram. So mostly for metal oxide you will only get like that. When you go for a carbon based system, you will get around more than 1000 or 1500 meters square per gram. So when we characterize the material through SEM and TEM, we got some nanorod morphology. You can see that for a secondary phase induced system, apart from the nanorod, you can also see some crystal phases over the nanorods, which indicates the formation of secondary phase within the system. Now the beauty here is when you introduce the secondary phases, the capacitance of the material was found to be drastically increased. So you can see that the CV response here, we could see for a normal nickel cobalt oxide system, the current range is around 20 to 30. That's a higher end. So when you go for a CV, when you go for a mixed metal oxide system, it has been increased twice or thrice. So the current range is also very high. So from this we could get some clear conclusion that both it exhibits a pseudocapacitor as well as the performance of the material will also increase after the introduction of these kind of secondary phases. So next we did some kinetic studies to calculate the capacitance diffusion behavior of these electrodes. So we can carry out the CV recordings at different scan rates, and from their peak current there are some calculations through which you can differentiate the diffusion capacitance as well as the diffusion as well as capacitance contribution within the system itself. So you could see that when you increase when you induce secondary phases in the system, the capacitance of the material, the capacitance contribution has increased to a higher extent. So this graph will tell you for each scan rate what is the capacitance percentage for each systems. When you take a nickel cobalt oxide alone system, for example, if you take in 40 millivolt per second scan rate, this is around say 50 to 60%. The same when you go for the capacitor and for the secondary phase induced system, the percentage increases to around 75 to 80. So this itself is an indication that there is an increase in the specific capacitance of the material. Right. Further, we proceeded with the GCD studies and found that at a lower current density, we could see a very good enhancement in the specific capacitance of the material. So we are for a normal system, we got around 220 farad per grams. So when you have a secondary phase induced system, we got nearly around 500 farad per gram. So it is a very good achievement. Of course, further studies like stability studies as well as the impedance studies were carried out. So the electrode was found to be stable at up to around we have reached now with the data shows around 2000, but we have reached around 5000 stable cycles. So still we are concentrating on improving the stability of the material. So this is on one hand, and the next one is we concentrated on the manganese cobalt oxide systems, where again the same kind of procedures were used for the preparation. You use urea as a structure directing agent in all these systems, so that when you have an urea, uh, the chemistry says that when there is an evolution of ammonia from the new urea systems, and it helps in the formation of the material to a greater extent. Also, it also helps in the orientation of material in a unidirectional way, so that most of the synthesis where they use urea as a precursor, we mostly obtain as nanorods in the system. So again, we carried out all the conventional material characterization techniques to confirm the material. And further, we did the morphological calculations, and finally to the electrochemical system. Again, you can see that the material showed very good pseudo-capacitance behavior from their redox features, as well as the galvanostatic charge discharge studies. So in addition to all these studies, we got interested in studying the impedance behavior at their electrochemical interfaces. So what did we do is we did some impedance measurement at different frequencies ranges and different potentials, and finally we could pick up the best Nyquist response, and we fitted it through an appropriate electrical fitting circuit, and we could found that there's some kind of pseudo capacitance nature has been arised for this material to exhibit is as a very good supercapacitor material. So from this R1 RQ like values, we could conclude that the material also exhibit a very good pseudo capacitor or some electron transfer reaction that is being taking place, which is responsible for the conducting behavior of the electrode. So having achieved all these things, then we thought of fabricating some devices based on that. So then we moved with fabrication of asymmetric supercapacitors, because asymmetric supercapacitor has a provision of both the charge storage mechanism to play to greater extent. So what we did is one electrode we fixed it as the carbon, another one electrode we fixed it as manganese cobalt oxide. So mostly activated carbon was used in these systems, which was fixed as negative electrode, and the manganese cobalt oxide was used as a positive electrode. So you can see from this graph that the black shows the response of an activated carbon, and the red shows the response of the manganese cobalt oxide. So it extended from -1 volt to 0.6 volt. So when you make it as a device, the voltage range extended from 0 to 1 volt. So the cell voltage reached up to 1 volt. And again, we studied all the conventional studies. Of course, there was a reduction in the capacitance when you come from the 3 electrode to the 2 electrode systems. And though the capacitance was reduced, the stability there was not much effect here, because we could reach around 5,000 stable cycles, and further process is also going on to improve the performance of the material. So this is on one hand, and the next work we are now concentrating is on the deriving carbon material from a biomass source. So we prepared a carbon from a biomass material. We did some optimization studies to improve their surface area. So from initially of around 700 meters square per gram, we improved it around 1,300 meters square per gram through some same chemical synthesis processes, right? Then the material was found to be promising. We have doing some initial studies, and also we did some prototype fabrications, like we took stainless steel bare electrodes, we coated the material, we made one as a positive and negative electrode, and electrolyte. Mostly all these things were carried out under the alkali condition. Mostly KOH was used as an electrolyte system, so the separator will be soaked in the KOH systems, and it will be placed between the electrolytes. So here what we did is for a single electrode we got around 1 volt. So we stacked 2 supercapacitor electrode in the same in a series manner. So the total cell potential reached around 2 volt, which we are able to power even a small LED devices. So this was a very promising results that we had done in our laboratory. So this is completely based on a symmetric supercapacitors with the carbon as their main electrode source, and there is now we are now focusing on improving it with hybrid devices, where one electrode will be the EDLC electrode, and other will be a material with a pseudo capacitor behavior. So this we are now concentrating on making it as a prototype. So hope we will achieve it soon with very high voltage and capacitance. So the of course, when you know that when you stack the materials in a series, cells in a series manner, you can achieve around. Uh, so what we did is we achieved around 2 volt. Of course, there are reports in literatures where even 10 volt was also achieved. This was a report by Mr. Satish, I think Satish from Sikri. He has stacked an electrode. This is a asymmetric electrode with one on a nickel hydroxide electrode, other one is a carbon based material. So he reached around 9.5 volt, if I remember correct, both with a series as well as parallel stacking fashion. So this stacking has a great extent in the performance of the material. Like you have an extended cell voltage that you can see it from the CV graph. So when you stack the number of cells, when the stacking number of cells increases, you could also see the cell voltage increases. So it has reached around 9.6 volt in the system. Of course, there will be some compromise on the specific capacitance of the device. So that has to be improved through some material synthesis technique or material performance techniques. So when you come to this kind of prototype fabrications, apart from normal this kind of prototypes, we also have different studies through different type of cell manufacturings. Like for a simple system, use a swage lock cell. Next, we use a coin cells for further studies, and then we go for pouch cells, and further finally for a market output, you need to have a cylindrical cell as your systems. So these are the several stages which you have to pass through for your material to get success to the commercial end. So that is what we'll still are working on. So nowadays, in your recent thing, many more materials has also been explored to a larger extent. So like apart from this carbon and other materials like metal nitrides and MXenes are also being used now. Metal organic frameworks are also being used, and also the application has been extended to widely extended to greater extent. Like there are also be as a piezoelectric device. They can also power as a self-healing supercapacitors. Sometimes they couple it with the solar system to power the devices, or the energy that is generated in the solar cells can be stored in the supercapacitor, which can be used whenever that is required. So all these applications are being done. Even black phosphorus are also being used as a very good supercapacitor materials. Of course, they don't go beyond that Lakshman Rekha. What we see that they exhibit either EDLC or pseudocapacitor behavior. So when you come to metal organic frameworks or perovskite like of structures, they exhibit a pseudocapacitor behavior. And when you come to the black phosphorus or MXN kind of things, they exhibit only an EDLC kind of behavior. So you don't expect any electron transfer that is being taking place in the system. So these are the emerging materials that are being presently focused upon, which has very good promising applications, promising performances in the future. Who knows, maybe in maybe after quite a 5 to 6 years, um, you can have a supercapacitor commercial device with these kind of materials in the market. Of course, when these are the material part that we focus on, and the final thing which I want to touch upon is the electrolyte. So electrolyte also plays a very important role in the performance of the devices. Like you take a carbon carbon material, you take a carbon material, metal oxides. They can be used as both aqueous as well as organic electrolyte systems. So the use of these electrolyte has also have their own limitations. So when you use an aqueous electrolyte, you cannot go beyond 1 volt or 1.5 volt, because there will be an interferences of water oxidation during the systems. And other one is the when you employ an organic electrolyte, though organic electrolyte not that much conducting, we used to add some specifically salts like tetraalkyl ammonium bromide or something to improve the conducting nature. So in those cases, you can extend the cell voltage to more than 2 to 3 volt to the system, right? Even for See, there are different kind of electrode also exhibit the different cell potential. If you use a KOH, it won't go beyond 1.1 volt or 1.2 volt. So you can use a neutral electrolyte, so you can reach up to 1.6 to 1.7 volt. So like this, electrolyte also plays a very important. And the next one is ionic liquid is also gaining some very much importance as an electrolyte here. But the only problem is its viscosity in the system that is being hindering in its progress. So when you use an ionic, you can ionic liquid as an electrolyte, you can even achieve a cell voltage up to 4 volt as a greater extent. So these are all aqua or liquid medium electrolytes. There are also several other electrolytes like solid state electrolytes are now being used in supercapacitor application. But again, there is a problem that the conductivity of the system is also very poor in solid state systems. So thus research is being focused in those direction also to improve its performances. So with this, I hope that I have concentrated mostly on the material part of supercapacitors and how the criteria on which you have to choose a material for supercapacitor applications, and what are the process through which you have to study, and how to go further for a device fabrication level. So with this, I end my talk, and I acknowledge the funding agencies, DST SCRB and UGC DAE CSR project, and PG IAS and their management for fellowships, as well as the lab facilities, and also my research scholars who work tirelessly to bring all those results. And finally, thank you for your kind attentions. I'm most welcome to receive your questions, and we can have good discussions on this. Thank you. Thank you, sir. Ah, so for the two electrode system, first you should study the three electrode system perfectly. So you need to have the capacitance. You need to know the capacitance of both the materials, both the positive electrode as well as negative electrode. And I have given a formula here, like mx by m minus equal to the cs by cv into their potential limits, that I'll show you here. Just a minute. Sorry. Yeah, this is the one. So the ratio of the mass loading should be in such a way that it should be near to 1. So for that, you should know the capacitance of both the positive electrode as negative electrode, and also their potential limits. So you have to apply those values in this equation. You have to get the that is why you have to do it. Is it is card listen upon call. Any more questions? Yeah. Yes, sir. Thank you so much for giving this opportunity. Also, I hope to have further interactions and collaborations with you and your students in future. I also invite people who are attending here to visit our labs. You can also use our facilities. We can even collaborate to work further. So you're always free to reach me at any time. Thank you. Thank you so much. Yeah. Thank you all. Thank you so much. Yeah. So can I leave, sir, now? Yeah. Thank you. Thank you, sir. Yeah. Sure. Thank you. Yeah. Thank you so much.
Sir, okay, sir. Can you hear me? Okay, sir, please.
Good noon to all. I'm very happy to invite our chief guest, Dr. S.N. Karthik sir, working as Assistant Professor, Department of Chemistry, Badia University, Coimbatore. And he obtained his PhD from Alagappa University, Karaikudi in 2008 and has served as postdoctoral research associate and research fellow in an hour of Pusan National University, South Korea, and Dr. D.S. Kotari Postdoctoral Fellowship Scheme, Indian Institute of Science, Bangalore. And his area of research include dye and quantum sensor solar cell, battery, supercapacitor, and sensors. And he received a Best Paper Award, Royal Society of Chemistry, UK, and Best Scientist Award, received from Natural Science Foundation, Coimbatore. And he received a sponsored project from UGC startup, grant worth of 10 lakhs. And under his guidance, two research scholars work for their PhD. And he published more than 50 international journals and 20 papers in international conferences. And with his introduction, I would like to invite Dr. S.N. Karthik sir to deliver a keynote address on a strategic approach for developing high energy density supercapacitor. Sir, please.
Thank you, madam. Thank you for your nice introduction.
Thank you, sir.
I hope my screen is visible to all.
Yes, sir. Now it is.
Okay. Thank you, sir. So these 2 days webinar, you may have many idea about supercapacitor battery storage and energy storage devices. So here today we are going to see about strategies approach for developing a high energy density supercapacitor, right? So this is my area of research in Bharathiar University. Basic research I am doing in electrochemistry. Then in this application for the electrochemistry in the dye and quantum dot sensorized solar cell as well as perovskite solar cell. And this is the energy conversions material. According to that energy storage, I am doing some work in the supercapacitor and batteries like aqueous and lithium ion batteries and some electrochemical sensor studies. Okay, before going to see about the capacitor, before I have to give some introduction about not only battery, energy storage device, energy conversion also very, very important in our day-to-day life, right? So here need for eco-friendly energy resource. So we have a lot of energy devices, energy storage devices using in our day-to-day life. For example, in this laptop and computer, each and everybody have their own mobiles, whatever it may be. We need energy for that smart devices. Okay, so because of some nowadays people are using for this energy resources, for example, petrol and diesel and so many things we are using. But the thing is, so many, I mean, environmental pollution may happen, right? So this is the by the end product of this energy resources, the like carbon dioxide, the global warming is occurs. So we have to stop this is immediately. Otherwise, we cannot save our earth. Okay. So we have to know it. What is that energy resources like for fossil fuels, like coal and gas and oil, everything comes under the fossil fuels. So the end product of these things is our carbon dioxide. So due to the more concentration of carbon dioxide in our earth, it will create the global warming. Okay, so because of this, I mean, temperature of the earth is increased. So the level of sea level is also gradually increased. So we have to stop this immediately. So many kind scientists, they are thinking about that energy resources, renewable energy resources. What is the renewable energy resources? Here you can see this is the hydro energy and solar energy, tidal energy, geothermal, biomass, and wind. What is the difference between this fossil and renewable? Means renewable we don't have much side. I mean, the end product is not harmful to our environment. This is green energy mostly. That's why people are moving towards the renewable energy resources. Okay, what is the need of energy storage device? Here using, for example, in our home, we are using water, right? Municipality water, as well as we are using some groundwater. So for that water, we need some water tank in our house. Then only we can use that water whenever we need. Okay, like that here we have lot of energy resources, but even though we need some storage device, then only we can use that energy whenever we need. Otherwise, very difficult to use the energy directly. Okay. Okay, what kind of energy storage devices available nowadays? We can classify that like a supercapacitor and a capacitor, batteries and flow batteries. Among them, we are focusing only supercapacitor here. He is Professor B. Conway is the first supercapacitor inventor with the material of ruthenium oxide as the active material. He is the father of supercapacitor. So this is the graph which are putting in power density versus energy density. So usually for battery, we have a high energy density, low power density. For that supercapacitor, we have high power density, but low energy density. So what is the thing here? So we want to increase the energy density in supercapacitor material. Why? What is the necessity we need? You see, for batteries, we are, for example, we are using mobile phone, right? For that, we have to recharge our batteries. It will take around 2 to 3 hours, depending upon the mobiles. If it is a smartphone, it will take more than 2 hours, right? 2 to 3 hours. After that, we can utilize that energy. For smartphone, it will come minimum around 12 hours to 24 hours, maximum 24 hours. We can utilize that mobile phone if we are putting charge around 2 to 3 hours. If we are because we in batteries we have only high energy density but low power density. What is we can easily within 5 minutes if we charge the battery, we can utilize that device up to 24 hours. If it is happen means very good, right? Because for travel we need a charger and if we increase the power density in supercapacitor, we can utilize and like we can charge the battery or by battery versus that supercapacitor very fastly. Then we can discharge the current. It will take long time, around 12 hours. That's why we are thinking to increase the energy density of supercapacitor materials here. So he wrote a book, Electrochemical Supercapacitor. It has some fundamental things. If anybody interested in supercapacitor, you can go through this book. E-books are also available in the internet. If anybody want to start research in supercapacitor, also you can go read in this book, B. Conway books. Okay, here we are going to see about the difference between supercapacitor and batteries. Okay, according to these parameters. So energy storage we can use here. Supercapacitors means watt second and battery means it come watts hour. So here charge method is here we are reading voltage across the terminal. Then battery means constant current and constant voltage we are using. The power deliver. This is the main thing. The main difference between the supercapacitor and the power battery is the power delivery. This is a rapid discharge. Okay, supercapacitor has a rapid discharge. At the same time, battery has a very long time to discharge. But if for charging, the same thing. He's a rapid charging, but it will take somewhat long time to charging also. So the time of charging and discharging, it maybe comes milliseconds to seconds in supercapacitor. For battery, 1 hour to 10 hours. So here form factor means the size and design of the storage devices. It may be very small, but it may have both small to large. Then weight it comes to 1 to 2 gram for a supercapacitor, but in batteries you have 1 gram to more than 10 kg. But nowadays the due to the so many research in supercapacitor, we are making a very big size supercapacitor. It may come around more than 10 kg also. Then you see the power density of this supercapacitor may comes around 1500 watt per kg. But here the power density is comes around 3000 to sorry, I did some mistake here. So actually power density of supercapacitor comes around 3000 to 40,000 watt per gram, and for batteries it comes around 1500 watt per kilogram. And the energy density it is have 1 to 5 watt per kilogram, lowest one, and the highest is battery. It has 8 to 600 watt hour per kilogram. Then operating voltage is more or less equal for this. The operating voltage depend upon the electrolyte. If you are using organic electrode, it may come around 3.5 volt maximum. If it is aqueous electrode, it may come around 1 to 1.2 volt. So life cycles it is very high, like 1 lakh cycles, but it has 150 to 1500 cycles only. The operating temperature also more or less equal here. So before going to see about the full detail about supercapacitor, I am giving small introduction about terms of using in the battery into supercapacitor. Capacitance, we are using capacitance, the term in supercapacitor, capacity in the term using in the batteries. So capacitance means it's the expression of the ratio of the electric charge on the two conductors. And I mean electron conducting conductors while we are applying some potential. So the unit of this capacitance is Faraday. Okay. At the same time, in battery, well, the current that is drawn from this voltage is dropped to lower than the certain value. So here the up to certain voltage we can draw in the energy from the device. This capacity is comes in the battery. Capacitance belongs to the supercapacitor. So next one is the gravimetric capacitance, aerial capacitance, and volume. It has the three capacitance. So it has its uniqueness. The gravimetric capacitance is, gravity means weight, right? So here we are using the capacity, measuring the capacity according to the mass per mass. So the unit of this specific, gravimetric capacitance Faraday per gram. At the same time, aerial capacitance, we can measure the capacitance using the area. Area means length and breadth. So we can use centimeter square, length and breadth. Okay, so the unit of this is Faraday per centimeter square. Then another thing is the volumetric capacitance. We can measure the capacitance at the unit of mass of the active material. That's it comes both 3D like 3D, that length, breadth, and height. So using this formula, we can find out the volumetric capacitance. The unit of this capacitance Faraday per centimeter. So according to our device, we can calculate the gravimetric capacitance, aerial capacitance, and volumetric capacitance. So we know about the cyclic voltammetry. So to find out the materials behavior, materials property using this electrochemical device, cyclic voltammetry, we can see the changes between the interface of the electrode and the electrolyte. So we are using some solid electrode. Using some liquid electrolyte solution. What happening between that electrode and electrolyte? How can we find out? Because we cannot find out any electrons, any atoms movement in this device or any cells, because it is very small in size, right? Femto level, we can see the particle size up to 40 micrometer. Below 40 micrometer sizes, we cannot see with our naked eye. So for that, we have to find out the electron movement. Charge discharge studies, galvanostatic charge discharge. For energy storage device, we need very important. We need these studies, because we have to find out while we are applying some, we have to calculate the capacitance for supercapacitor and the capacity for batteries. From this instrument, I mean, galvanometric charge studies only, we can calculate all those things. While we are applying the constant current, we can measure the what kind of changes happening in the voltage with respect to time. So from this we can get the calculate the capacity as well as capacity of the particular device. I will explain detailedly why picture here. So another important tool is electrochemical impedance spectroscope, right? So I already told you we cannot find out any electron ions or movements inside the device or cells with our naked eye. So we need some instrument's help. Here it will tell the resistance of the particular two electrode setup. Whether we have high conductivity or high resistance, everything we can find out from this impedance spectroscopy. This is two electrode setup. You see, this is half cell, one half cell. This is another half cell. In between, we are using some electrolyte solution. So this is the device circuit. You see, for solid, we have the first we will get the resistance for the solid material. The second one is the interface. Interface means I already told you that electrode and electrolyte interface. That what happening, how much resistance we are getting from this electrode electrolyte interaction, we are getting the value from the second one. And third one is the electrolyte solution, how we are getting some resistance in the electrolyte. Everything we can find out from this impedance spectroscopy. This is the graph which we will get from the instrument. This is the type of supercapacitor. Nowadays, so many types they are classifying according to so many terminology. But here I am giving some short method. So we can classify the supercapacitor by three classification. One is the EDLC electrochemical double layer capacitance. Second one is the pseudo capacitor, and third one is the hybrid type. Okay, so EDLC means electrochemical double layer capacitor. Here we are using some activated carbon based material, graphene. Everything comes under the electrochemical double layer capacitor. What is the electrochemical double layer capacitor? We will see later. So the second one is the pseudo capacitor. Pseudo capacitor means it will give some not it will won't depend upon the only electrochemical double layer capacitor. It have some redox reaction also happen on the surface of the material. So for example, we can use here redox. I mean, pseudo capacitor is some conducting polymer like PANI and PAN, and metal oxide like ruthenium oxide, manganese oxide, cobalt oxide. Some noble metal also using here as a pseudo capacitor. The third one is the hybrid capacitor. We can classify hybrid as two types. One is the asymmetric supercapacitor, another is a hybrid capacitor. The asymmetrics also comes under the hybrid, but it is somewhat little bit different. Here asymmetric means here everything we can use the material for both anode and cathode, we can use the same material. But asymmetric means we can use some different material. For example, we can use some activated carbon versus some metal oxide. It will come some asymmetric supercapacitor. The same thing like here also. We can change the anode and cathode material here. So this is comes under hybrid material. Then hybrid capacitors means we can use here, we must use some battery type material. Either it is anode or cathode. We will which potential it has, according to that we can use that whether it is anode or cathode. But we should use some battery material versus some EDLC material. At the same time, battery type versus some pseudo capacitance materials. So what kind of electrode materials we are using? We have to know it some capacity material of a non-faradic and faradic. So if it is non-faradic means it is a capacitive behavior. That is a carbon-based material also comes under the non-faradic capacitive, right? For the faradic means it may happen under surface redox and intercalation. What is the surface redox? These all those things comes under the pseudo capacitor. Okay. So it may be partially faradic. So surface redox reaction like metal oxide, already we have seen metal oxide and polymer and MOF, MX in everything. But intercalation means it is also all material cells come under the battery type material. So these two things comes under the supercapacitor type. Here intercalation reaction happen in this electrode means it will comes under the battery type. So this is faradic and this one is the non-faradic type. For Faraday, we are using carbon-based material. It should have high specific surface area. Compared to some other metal compound, carbon-based material have the high surface area, and it has good intra-intercalary particle conductivity and highly porosity. Everything it will comes on. It will have carbon-based material have all those things. Then only we can get good electrolytic ions. Diffusion inside the porous carbon material, then only we can get good capacitance. So these are the factors capacitance response for the various material here. Okay, for Faraday material like pseudo-based capacitance, it should be a fast redox active material of the metal at a surface. So the redox reaction happen only on the surface of the material. It should be fast. It should not intercalation inside the material. If it is intercalation, it is comes under the battery type. So other the thing is we have to increase the electron conductivity. So we are putting some dopant like heteroatom, like nitrogen, sulfur. So many things we are using in the carbon-based material. That is also comes under the pseudo-based materials. Then another thing is the 2D material. Also, we are nowadays so many research going on this 2D material for the pseudo capacitance, like molybdenum sulfate, tungsten sulfate, vanadium sulfate, everything comes out of this. For battery type material, how can we use means we here it will highly opposite like pseudo based material. What means here the slow electron diffusion kinetics and reversible redox reaction will happen. So it should happen that the redox reaction should happen very slowly. So it will go inside that it will penetrate inside the electrode material. Intercalation may happen. So then only we can get high energy density. Then only it can use in the battery devices. At the same time, it should be highly crystalline in nature. If it is not highly crystalline in nature, the conductivity also low. Another thing, we cannot use reuse that same structure after electron enter the material after decalation happen in this material. Both the time it should not be affect the crystalline structure. Then only we can use the battery devices or the battery devices in this material. Here the deeper integration should be happened compared to the pseudo based material. We have already clearly see about the materials here and storage. Okay, here you can see the storage mechanism. Here, while we are applying, I already told you, while we are applying the applied the potential difference, it will create some charges on the electrode. Then the ions, from the electrolyte, the ions are attracted by the opposite charged ions. So this is a charge completed one. After charging, we can use that electron for our use. This is a discharge type. So this type of mechanism comes under the EDLC, electro double layer capacitance. Just the charges are absorbed on the material. No reaction happen on the surface of the material. For this, we are getting cyclic voltammetry like this, square type one. For charge discharge, I already discussed with you. Charge discharge also, we will get the exact triangle shape. According to the pseudo capacitance, here we can see some fast and reversible reduction on the surface of the electrode. So here not only the absorption, at the same time some redox reaction happen on the surface of the material. So then only we can get that so cyclic voltammetry. We couldn't get like this exact square. We are getting somewhat like these kind of things happen in the pseudo capacitor. That's why we are calling this is the pseudo capacitor. For charge discharge also, we cannot get the exact straight square shape of the charge discharge. Voltage versus the times curve. We are getting somewhat imperfect curves. So this is one kind of pseudo capacitor. Yeah, okay. Then here hybrid, third one is the hybrid capacitors. I already told you that we can classify these two things as the asymmetric capacitor and the hybrid capacitor. Before going to see about this graph, I would like to give a brief detail about this. What kind of curve we are getting from batteries and asymmetric supercapacitor and hybrid capacitor. Okay, here you see the blue one. This is the anode part. Okay, and then right side, this is the red one is the cathode part. If you are getting some redox peak, right, like this Faradic reaction happen, okay, in anode side and cathode side. If you are making these two things as the device, we are getting this curve by the cyclic voltammetry 3 electrode setup, right, separately for anode and cathode. If you are making a device, we are using this material as the own electrode, another this material is the another electrode, we can make it the full cell. That is called full cell. Once after that we are running means we will get these kind of redox reaction. So these kind of cyclic autonomy we will getting for the battery. Okay, if suppose we are using the asymmetric experiments, this blue color one is the negative electrode, the half cell electrode. The red one is the another positive electrode. It's a half cell reactor. If you make a electrode both combined, we will use we will get here square shape one cyclic autonomy. This is a full cell. I mean 2 electrode. So here you see here we can get pure redox behavior. It comes under the battery. We can find out the difference between battery and the supercapacitor here. Nowadays, so many people are confusing, right? Which behavior will comes under the battery and supercapacitor. We can find out from here. So if we are using these two things, we will get the full cell curve like a square type. Another thing is here, hybrid cell means I already told you we can use some one side we can use battery type, and another side it may be pseudo capacitor type or EDLC material. So for example, here we are using the negative electrode, we are using some electrochemical WR capacitors, and here we are using some pure battery type material, right? For from off cell we are getting this curve. If you are making the device using this both material, the anode and cathode device, I mean electrodes, the full cell we are getting like this. You see, this is called hybrid capacitors. Okay, here we will getting the optimum level of power density and energy density. If here you see this is a CV for battery. If suppose it is the charge discharge curve for batteries, mean here this is the half cell curve. For blue color one is the anode and red one is the cathode. If it's a full cell, for battery you will get the charge discharge curve. We will get like this. Okay, at the same time for asymmetric capacitor, this is the half cell. Red one is the positive and blue one is a negative thing. If it is a full cell, we will get the I told you right, somewhat the triangle shape. In hybrid, the same thing, but we will not get the exact square here. I mean triangle here. We will get like you can see here they are easily and clearly explained how for the single, I mean half cell, we will get the charge discharge curve, and if it is a full cell, how we will get the it will happen. I mean it will get potential versus time. So now you can easily understand why we are making like this type of device like asymmetric and hybrid, because we have to increase the voltage window here. For example, here you see the RGO, reduced graphene oxide, it will give the I mean current density in this particular window like 0 to -8 volt. Okay, at the same time if we are using the same RGO with M1O2, here you see we will get positive side active material. Okay, so if you mix these both, mix means if you make a RGO as the one electrode and if you make a RGO with M1O2 as the another electrode, we can make a device. This is half cell CV, I mean cyclic autonomy for the half cell, 3 electrode setup. Then if you come in and if you make a 2 electrode, then if suppose make a 2 electrode for this material, we will get the capacitance, I mean CV curve like this. So here it will give broad window, voltage window, right? So to increase this voltage window, we are using this asymmetric capacitor. That like that, the same thing happen in the hybrid capacitors. We have to increase the capacitance, voltage. Why we should increase capacitance and voltage means for increasing energy density, we need this both. I will tell you later. So here you see we are using some carbon based material. It will active in the negative side. Another nickel cobalt based material, it is active in the positive. If you mix, I mean combine both electrode in the 2 electrode setup, we will get the curve like this. So we will get more voltage window. So overall, I can tell what kind of things is affecting the cell performance here. Till now, we are seeing about the according to, I mean some classification of the thing. Here we are seeing the overall device cell performance. So for capacitance about that active material, high current generation, and electrode thickness and mass loading. These are affect the capacitor. We have to optimize each and everything. It should be good active material. It should be optimum electrode thickness. It should be optimum mass loading. Then only we can get good capacitance. Then only we can get the good energy density. Here you see the formula for energy density, watt hour per kilogram. So 1 by 2 CV square divided by 3.6 for energy density. If it is power density means we can use that energy density multiplied with 3600 divided by discharging time. So from this formula, we can calculate the energy density and the power density. The operating voltage is very, very important here. I told you we are increasing the operating voltage window. That's why we are using some asymmetric and hybrid supercapacitor here. The operating voltage we are using it mainly depend upon the electrolyte solution in this the device and the cell configuration. It will affect the operating voltage. We will see later. Then resistance. Resistance also affect the cell performance. What kind of resistance it may happen? Active metal should be more conductive. While we are packing, it should not increase the resistant, and current collector should be a good conductor compared to other material, and its lifetime should be good. At the same time, here we are using some binder material. It should be not much. It should not give not much resistance. So this is the overall things which are affecting the performance, cell performance, supercapacitor cell performance. So here I can easily explain the energy density and difference between the energy density and the power density. You see here the marathon race. Is the Mutai is the best marathonist. Okay, so for marathon race, it may come around more than 20 kilometers. It will take long time, around 2 hours to reach the destination, right? So for this, he need more energy. If he has more energy, only he can cross that much distance with around 2 hours, right? Here you know that Usain Bolt, he is the fastest sprinter in the world. So he crossed the 100-meter race within some seconds, around 20 to 24 seconds. So for that, he need more power compared to energy, right? Within fast, limited time of duration, he reached the destination. So this is the main difference. For marathon race, we need more energy. For short distance race, we need more power. So Bolt has high power density, and Mutai has more, high energy density. Okay, we can tell another example also. If you are pouring, drawn the water from the some water can, it has a small mouth, right? So it will take a long time to drain the water from the can. If it is bucket, because it has a bigger mouth, right? We can within a second we can drawn all the water. So it has this is a example for the high power density. This is the example for the high energy density. I already told you energy density formula is equal to 0.5 into CV square. So here the energy density mainly depend upon the capacitance as well as the voltage. That's why we are increasing the capacitance and voltage windows, right? Then only we can get good energy density for supercapacitor material. So already we have seen some material according to that carbon based one, pseudo and battery type things. Here I would like to give small introduction, things about electrolyte also, because if we have very big electrolyte ions, like we have three, here I am focusing on the aqueous electrolyte. For aqueous electrolyte, we can use acid, base, and neutral electrolyte. For acid electrolyte, we are using some sulfuric acid, and for base, we are using KOH. For neutral, we can use KCl or sodium sulfate. Okay. So the size of the ions also affect the capacitance. If we have small size, means it will absorb on the surface area, more number of ions absorbed on the surface area. You know about the nanotechnology, right? If it is the ion size is very big, so some limited amount of the ions absorbed on the surface area of the electrode. So according to this size of the ions, it may affect the capacitance, right? Other things, the height is, I already told you the size of the ions. For example, here potassium hydroxide KCl and KNO3 and K2SO4. So we are taking CV for this different electrolyte solution. So here this one is very, it has very small current density compared to this black one. Black one is the KOH. This dotted blue one is the K2SO4. Okay. So why we are getting like this means, you know, the anionic size of OH minus and chlorine minus and NO3 minus. It have very small size, around 0.34 nanometer. So it has more number of ions adsorbed on the surface area of some active material. According to the SO4 2 minus, it has somewhat bigger size compared to these ions. So it take the number of ions. You see, consider this small area here. 3 ions are adsorbed here, but here 5 ions are absorbed. So size is very plays a vital role here. So most of the research people we are using in for base, we are using potassium hydroxide electrolyte, right, to improve the capacitance. For device also affect this capacitance. For example, here we are using some parallel connection. We know that the serial connection and the parallel connection. If you are getting a serial connection, we are getting some lower capacity, I mean voltage. You see, for a serial connection, we are getting some separate device voltage. Then while you are connecting the series connection, will give the same voltage here. If it is parallel connection means, you see the first one device, it have some zero point 0.7 voltage, mean 0.7 or 0.8 voltage means, if you are connected it parallelly, I mean parallelly for all things, you see the voltage it may be increased. So here this is no need, because we are seeing about some chemical point of view. Even though device connection also will affect the voltage of the supercapacitor. Okay. So electrolyte here I already told you, we are using some aqueous electrode and non-aqueous electrolyte, and solid state electrolyte also we are using some redox type active electrolyte we are using. We are focusing so many research on the aqueous electrolyte only compared to organic electrolyte, because it has some safety issues and some we cannot hold the organic electrolyte very long time. So many research going on the aqueous electrolyte only, right? Okay, this is some things how it is affect the electrolyte. Okay, I will give this example for easy understanding. For example, we are using here manganese oxide material as the electrode material. Here I am they are I mean scientists, they are using for a neutral electrolyte solution. Okay, here they are using alkaline. They are changing only electrolyte. So for this neutral, they are getting, you see, around 1 volt potential current in this 3 electrode setup. And if you are in the sorry in the, this is the 2 electrode setup. In the device they are getting around 400 seconds. This is the highest capacity, you see, around it will give 600 millifarad per centimeter square. If it is going with some alkaline material like KOH, the CV of this KOH, you see, it comes like pseudo capacitance behavior, and charge results also not that much. But initially it is giving more than 1000. But here see, after 2000 cycles, it is giving only the capacitance almost 98% is retained here. But you see the same 2000 cycles later, we are getting the capacitance almost 50% of the initial one. This is what happening inside, we will see here. So if you are using KOH as the alkaline neutral electrolyte, sodium sulfate are using as the neutral electrode, it will affect while during charge discharging process, the electrolyte also should not react or affect surface of the electrode. So here electrolyte is also play a vital role. Initially we are getting around more than 1000 millifarad per centimeter square for the same electrode, but here we are only half of the amount, around 600 millifarad centimeter square only. But even though the life cycle, I mean cycle is very important. Once within 2000 cycle it is degraded means we can't use in this device purpose. So it should not, that electrolyte we have to check the electrolyte, it should not react with the surface of our electrode. Then some how can we increase the voltage? Already I showed some figure, even though here I am explaining using the material, somewhat material. Here you see the green color one is the neutral electrolyte we are using. The blue color one is the alkaline, and red one is the acid. So here you see for carbon based material, we can use both negative side and positive side active material we can get, right? But for this another kind of carbon, it may active if in negative side, in alkaline solution it may active in negative side. then an acid, it may active in the positive side. Like that, ruthenium oxide also both active material. Some material it have only in a neutral material it have only negative negative side active, negative potential active electrode material, and some is very active in the positive side according to the that electrolyte. So we can choose from this kind of things which material is active in which electrolyte. Then how can we make a electrode? We take one side negative active material, another side positive active potential material, and if we make a device, we will get more window and we can increase the voltage, and as well as we can increase the capacitance. It will increase the energy density of the device. Okay. So nowadays, so many materials we are using. Already I told you about the carbon-based material and metal oxide. Nowadays, Semaxin also they are using, and for pseudocapacitor conducting polymer, because people are focusing for a flexible supercapacitor device. For that, people are concentrating the conducting polymer. So then only we can get some flexible based device. So many researchers are focusing the conducting based polymers, and now the because of the good conductivity, electrical conductivity, so many research are going in the transition metal chalcogenates also, and metal organic frame also. Recently so many research are focusing because of the surface area. Here the surface area is very important. Then if you have more surface area, we can get more capacitance. That's why recently so many researchers are going on the MXN as well as metal organic framework. So here I am telling about the how we are, fabricate the electrode here. This is I downloaded it from the internet. You can see in the internet also. So first we have to make paste. We can make a paste using our material. Okay, active material. We can usually using 80% of our material and 10% of some carbon-based material and 10% of some binders like PVDF, and make a slurry using the NMP solvent. We can make it like this. This is the NMP solvent. We can make it the slurry. Then this slurry is, after making the slurry, we are coated on this some substrate. This is the copper foil. Using Dr. Blade coating method, we are making the electrode. Now electrode is ready. Now how to make the device we will see here. So this is the aluminum foil, another is the copper foil. This is the leading material. This is the separator. We are Wattman filter paper we are using as the separator in our research purpose. So we can make it like we can assemble the cell. So here this is the one electrode, and we can put some separator in between them. Another, we can keep the another electrode on this separator. So this is the pouch type cells. We are taking 2 leads, 2 electrode setup. After making this, we will seal this one using some aluminum foil. So we are sealing this using some aluminum foil. So now the device is ready. Till now, we have seen about some basic things and important parameter of supercapacitor. Then what kind of research is going on nowadays in this supercapacitor? We will going to see about that. So here we prepared some metal chalcogen. I told you some metal chalcogen, they have more electric conductivities. That's why people are focusing. some metal chalcogenates based material. Here we focused on iron sulfide, disulfide, along with, I mean, hybrid RGO with iron sulfide material for supercapacitor device. Here first we are preparing two material. One is the iron sulfide, another one is the RGO with iron sulfide. For iron sulfide, we are using iron chloride as the precursor material, and triethanolamine we are using here hydrogen hydride as the reducing agent. Then we are keeping this solution in the hydrothermal unit around 200 degree for 24 hours. This is the hydrothermal unit. Then after 24 hours later, we will cool it down in the room temperature and we filtered it using water and ethanol. After drying overnight, we will get the material iron sulfide. Here we are making some micro flower size mean shaped iron sulfide. The same thing we followed for the RGO with iron sulfide preparation. Here instead of RGO, we are putting only graphene oxide. After the reaction, it be converted to the RGO here. Here the precursor for RGO is graphene oxide, and the same thing we used here. The same temperature and time utilized here, we will get the same thing, but along with the RGO. Iron sulfide formed along with RGO. So then, so we have to find out, right, whether any impurity is formed, whether what kind of metal chalcones it formed, whether metal chalcones or metal dichalcones. Everything we will confirm with the instrumentation help like XRD Raman. Here XRD we can find out some JCPDS standard values. We are getting pure iron sulfide. We are not getting any impurity peak like iron oxide. This is confirmed by the XRD. This is with the RGO. This one is the without RGO. Here RGO also we are getting peak around 24.8 degree into theta value in the plane of 002. So from this XRD we confirm that no impurity peaks and only iron sulfide formed. And here instead of GO we are getting RGO with iron sulfide. It will confirmed by the XRD. Carbon based material means we need Raman help also. Here for only iron oxide we are getting some in EG and AG and TG. Everything is like according to literature we are getting the perfect peak here. And the RGO with iron sulfide also we are getting Raman. Here Raman, you see the extra peak we are getting from around 1300 to 1600. So this is due to the RGO. This belongs to RGO. So it will confirm the presence of RGO with iron sulfide. So according to the SEM, we can find out the size and the morphology of the material. Iron sulfide we are prepared here. So this iron sulfide we are getting micro size particle like micro flower, but all are in the even size. You see, we are getting evenly distributed microflower here. Microflower means it will come around 3 to 5 micrometer. This is not nanoparticle, but our people are trying to prepare nanoparticle also in the same method. Here you see the flower like structure. This is a single flower microflower. This size is zooming size is around 600 nanometer. The leaf it may come some nanometer size, but we are trying to prepare the flower also in nanometer size. This is the only iron sulfide. This is iron sulfide with RGO. Here, this iron sulfide is distributed on the RGO surface. So it is also more or less uniformly distributed. It is confirmed by this same analysis. And this is the single iron sulfide. The base is the RGO. And another thing is we have, with the help of XPS we are find out the any impurities, small level of impurities is available or present in this material. Here according to the RGFES we are getting full binding energies was intensity. Here the for iron 2p, here for 2p 3 by 2 peaks comes around the 707 electron volt. At the same time for 2p 1 by 2 we are getting around 720.65. It is exactly correlated with the standard reference values. At the same time sulfide also we are getting 2p of around 163 and 2p 3 by 2 around 162. So here no oxides peaks occur. So sulfur oxide or sulfur dioxide not formed in this material. It will be confirmed by this XPS. Another thing is carbon based peaks. Binding energy will come around 285 electron volt. Here also we find out any external peak is there or not. Over here also no imprinted peak present here. After that, we are going with, after confirm all those things, we are studied the electrochemical studies for our material. For example, here both electrode we prepared for 3 electrode method. First we have to find out the activity of our material using 3 electrode. Then only we can go with for 2 electrode material, right? So here checked with our material in 3 electrode, according to the CV. Here we are getting around here, sorry, here I didn't give that 3 electrode method. Here only I am giving the 2 electrode results only. Sorry. Here you see, according to this 2 electrode, first for iron sulfide, we are getting the lower current density curve in between the 0 to 1 volt potential. At the same time, the same window we are getting for RJ with iron sulfide, we are getting somewhat high current density peaks. This is the some different scan rate of 5 millivolt per seconds, from 5 millivolt per seconds to 150 millivolt per seconds. So different scan rate, it will come around 50 percentage of capacitance retains while we are increasing the scanning rate. This one for the RGO versus and with RGO and without RGO specific capacitance rate here. Before that, we have seen here the charge. This is the CV, and we are going to see about the charge discharge. Here, the green one is the belongs to iron sulfide, and red one is belongs to RG with iron sulfide. For charge discharge curve, also we are getting more discharge time compared to the iron sulfide. We are getting RGO with iron sulfide have more discharging time compared with the only iron sulfide, right? So according to this result, we are calculating the specific capacitance, as I already told you how to calculate the specific capacitance. From that result, here we are using some different scan rate. Okay, so for that scan rate, we are getting for somewhat higher. For 5 millivolt, we are getting for higher capacitance around 120 millifarad per gram, and it will per centimeter square. It will decrease gradually. We checked up to 150 millivolt per seconds. Around it will come 60 millifarad per centimeter square. The same time, for only iron sulfide, it is giving less capacitance from 5 millivolt to 150 millivolt compared to the RG with iron sulfide. So here the third one is the, the electrochemical of third one is the impedance spectroscopy. Here for impedance, we took for iron sulfide as well as RG with iron sulfide. The green one is the iron sulfide. This is the zoomed one. Here, this is the iron sulfide. It have somewhat higher resistance compared to the RGO with iron sulfide. Blue one is the RG with the iron sulfide. Once we are after making the 10,000 cycles, after that once again we run the impedance study. No changes in the resistance. You see here, no change. The red one is the after 10,000 cycle. Later we can measure the impedance for the RG with iron sulfide. No changes, not much big changes occurs in the resistance of the RG with iron sulfide here. So the capacitance studies, I mean capacity retention studies have done here. So we made some around 10,000 cycles. According to the 10,000 cycles, around 90%, 80 to 90% capacity retention occurs for RG with the FES compared to the only iron sulfide, iron disulfide. So what is the thing? Conclusion here means the RG with the iron sulfide will give good aerial specific capacitor like 112 millifarad per centimeter square, and high energy density around 7.8 milliwatt hour per unit. At the same time, high power density also around 200 milliwatt per centimeter square. So the cycling impedance also it will come 90% over the 10,000 cycles. So here what is the problem means iron sulfide, while we are using here some neutral electrolyte sodium sulfate. So it will while you are running the charge discharge cycles, it will degrade that iron sulfate. It is react with that electrolyte solution. So the stability is reduced around 10,000 cycles, right? So if you are adding some RGO based material, carbon based material, it will avoid this kind of reaction in between the electrolyte and the electrode. This is the main advantage of RGO here. then only we can add this RGA with the iron sulfide. So iron sulfide give good electrical conductivity, so it will give good capacitance, but it easily decomposes. I mean, it is easily react with the electrolyte. To avoid these things, we are adding another material like carbon based material. This is another one. Here we are using some polyaniline based material. Already I told you we are using some polymer based material also in this supercapacitor device. Here we prepared sulfur nitrogen doped graphene quantum dot with the polyaniline nanocomposite for supercapacitor application. So in these studies, we are focusing the polyaniline and graphene quantum dot. Usually, polyaniline not highly stable in this electrolyte like iron sulfide. To stabilize these thing, so many research going on to mix this polyaniline with some carbon based material. So here we are thinking about not carbon based. This is also carbon based, but we are using here quantum dot, sulfur and nitrogen dot quantum dots. What happens the capacitor sense we will see later. Here you see this is the experimental method. We are preparing this already published one. We are taking these things from the literature. We are using some citric acid and thiourea. The weight ratio of 1:3 ratio. Mixed in the water and stirring half an hour. After that, we are keep it this one the hydrothermal around 160 degree for 6 hours. Then we are getting some green color colloidal solution. After vacuum drying around 48 hours later, we are getting like this type of SN doped GQD powder material. Another thing is the same material we are adding just PON in the we are adding this SNGQD in the PONI. So PONI means polyaniline. While we are making the polymerization using some acids, protonation, aniline mixed with HCl, then we are adding in this mixture, we are adding SNGQD in the 3 different ratio. Here ammonium persulfate is the initiator. So we will keep this reaction around 0 to 4 degrees Celsius. After 4 hours later, we are getting polymerization, that polyaniline mixed with SNGQD. After vacuum dry around 48 hours, we are getting the same photon like this. So after preparing the material, we have to finalize we have to check the compound, right? What happened inside the compound. Oh, here XRD will confirm that we are taking the only we are first prepare this pani without SNGQD also. So for that we are taking XRD here. Then we are preparing SNGQD without pani. That this peak corresponds to SNGQD. And these three is we are adding some different weight ratio of pani versus SNGQD, like 1:3, 1:6, 1:9, like that. So according to this XRD result, we are getting graphene quantum dot, because the peak occurs around 24.8. This belongs to 002 plane. So it confirmed that quantum dot formation. We will check with the some literatures also. For Pani, we are getting around peak around 15 degree as well as 20 and 24 and 27 degree 2 theta value correspond to the 011, 020, 200 and 121 planes. So this is also confirmed by some JCPD's data. After that, while we are missing these two, what happened in this material means nothing will happen. The intensity of the peak a little bit reduced, but no extra peaks comes here. So it will confirm that no impurity is formed here. Then we took HR term for graphene quantum dot. From that HR term, we are confirmed that the quantum dot formation, that means sulfur nitrogen doped quantum dot. Here, according to the SEM, you see here, first one is the Pani and the second one is the SNGQD with Pani, with 3 different concentration. This you see the surface morphology is somewhat agglomerator here. Here somewhat pores occurs. Here you see so many pores is occurs. It may have a higher surface area. And once again, the final, while increasing the concentration of Pani, it may come some agglomeration. So for you know, the surface area is very important in this supercapacitor study. So according to the SEM, it may have some more surface area compared to all these 3. So according to the XPS, we are confirm the material formation without any impurity peaks using XPS studies. Here we are another one is we are confirming the presence of nitrogen and sulfur in the presence of nitrogen sulfur in the SNGQD Pani nanocomposites. So these peaks represent no impurity peaks occurs in the material. It will confirm that. Now we are going to see about the cyclic automated studies. Here first we took some 3 electrode setup studies. Here we used Pani, only Pani we take that cyclic automated studies. You see, we are getting these kind of, it is run in different scan rate. We are getting lower current density of some peaks. At the same time, if you go with the nanocomposite 1, lower amount of SNGQD, we are getting somewhat the current density increased. The second composite also it is increased. The third one's automatically decreased. So according to this cyclic automaticity, it may give more capacitance compared to the other cyclic automatic, other composites, nanocomposites. So this one is the gravimetric, galvanometric charge studies, as well as the impedance spectroscopy. Here we are going to see the only Pani we are getting around, we are using some constant current like 0.5 ampere from 0.5 ampere per gram to up to 4 ampere per gram. So here 0.5 ampere we may get around 500 seconds time discharging time. At that same time, if we are using the compound 1, it may increase around 800, and 2 it may increase a lot, around more than 3500, but again it reduced for the third compound, right? So we can optimize the amount of ratio of SNGQD as well as Pani here. So we took some specific capacitance versus current density graph here. So the first one is the black one is the here Pani, only Pani, and the red one is the nanocomposite 1, and blue one is this one is the 2, this one is 3, right? So here you see we are getting more high, around 650 Faraday per gram physical capacitance value for this SNGQD compound 2 compared to other Pani as well as other Garnana composites. What happens that why we are getting only this good capacitance for only the second compound? We are analyzed with some impedance studies also. According to this impedance study, we are getting very the resistance for this second composite is very low compared to others. So according to these studies, while SEM, it shows the second one is giving good. The composition, ratio between SNGQD as well as the Pani is proper optimum ratio for the second composite. Then only we are getting some forced surface morphology material. Then only we are getting more surface area. That's why we are getting more good ions absorbed on the surface, and we are getting good conductivity material there. Then only we are getting good performance in the electrochemical studies. So here after making 3 electrode, we are using this second composite. We are making the device. From the device only we can tell the energy and power density. So here we run that cyclic voltammetry for the device. It gives some 1 volt potential. We are getting some peaks from 10 millivolt per second to 50 millivolt per second. Then for charge discharge studies, we are getting around 250 seconds. The impedance also very, resistance also very low here for this compound. So compared to other material, we are getting around 124 Faraday per gram specific capacitance for this particular nanocomposite, and energy density it will come around 17.25 watt hour per kilogram, and power density comes around 500 watt per kilogram here. The cyclic stability also around 90% for 1000 cycles only. Actually, I already told you with polyaniline, it is easily react with the electrolyte solution. So we did some 5000 cycles also, but we are not getting good result. The stability issues remaining same. as like only Pani. So we are focusing research to stability studies. That's why we are taking only here we are showing only 1,000 cycles instead of 10,000 cycles. So you may aware about that application of supercapacitor because so many talks already went. So for flight or bus or car, anywhere we are focusing to use supercapacitor material nowadays. So this is the small scale devices we are fabricated in our lab, spherical shaped onto pouch cells. So here I want to conclude my talk here. So for initially we have seen about some fundamental about the supercapacitor and the working principle mechanism and material activity and how we are fabricating device, everything we have seen. And we have seen about the difference between battery and the supercapacitor and what is the use of renewable energy sources, everything. Then second part we have seen about this some research paper, research article recently published from my group. We prepared some SNGQD with Pani nano composites and microflower like RGO with iron sulfide material. Then how we are recently we are going, I mean advanced research going on this world. How we are increasing, how can we increase the energy density in the supercapacitor material. Like that we are people are trying to increase the power density in the battery type material. That's why already professor told you what is the difference between supercapacitor and supercapacitor. Everything you may aware about that if you are watched this webinar. So somebody in our group we are making some preparing some supercapacitor material and we are trying to increase the energy density in this material. Some group they prepare some battery type material and they are trying to increase the power density of the material. So I'm grateful to my parents and my guru, Dr. P. Sivaswamy, is a retired professor in Anjak College, Sivagasi. Now he is working as the PG controller in Anjak College. And my well-wishers are also nature. I must acknowledge my PhD guide as well as my postdoc bosses. So first I have to thank my PhD guide, Dr. A. Subramania, head of the Department of Nanoscience and Technology, Pondicherry University, Pondicherry. And I thank my postdoctoral boss, Dr. Prem Kumar, Scientist Secretary Karakudi. And I must thank Professor Hiji Kim, electrical engineering department, Busan National University, Busan. He only thought about the solar cell, Dyson solar cell, perovskite solar cell. Everything I learned from his lab. And I have to thank, I am very happy to thank Professor S. Sambat, Indian Institute of Science, Bangalore. I learned a lot while I was doing some postdoc in Dr. Kothari Fellowship under in his lab. I learned some photocatalytic studies and basic electrochemistry from his lab. Finally, I thank some funding agency. First, I received around 1 crore project from South Korea while I was doing postdoc in Professor Hee Ji Kim lab. Research funding of National Research Foundation, NRF South Korea. And now I am working in Bharatiyar University. I received some fund from UGC and DST PERS and MHRD RUSA funds. So I have to thank all those funding agency from India. And I thank Bharatiyar University, Coimbatore, to provide a lab facility and very helpful to do my research without any resistance in this university. And finally, I thank the management and head of the Department of Science and Humanities of Dr. Salini Baki ma'am. And I thank Dr. P. Periyasamy to give this opportunity to interact with you people here, Nehru Institute of Engineering and Technology, Coimbatore. This is some of clips. I was doing my postdoc research in that Professor Hiji Kim lab. This is his research group. And he is the Professor Michael Greatcell. He is the father of Dyson solar cell. I met him at a conference at the Sangikyon University, South Korea. And this is Professor Sambasar lab, Indian Institute of Science, Bangalore. So this is my research group of 4 PhD scholars and 3 MSc students. So I have to thank all those things. This is Monique Clinton. And this is Jayashri and Akshaya and Lakshmi Sunil. They are mostly help to develop my lab as well as my research career in this Bharatiyar University. I thankful him. Thank you. If you have any doubt, please contact. Please interact with me. So thank you. Hello. Here. கேக்குதுங்களா? Hello. ஒன்றும் கேட்கல சார், சாரி.
I thought he's left the meeting. Please confirm once.
Can you hear me? Hello. Hello.
Sir, some connectivity issue. I think he has left. Let's wait for a moment.
கேக்குதுங்களா? Sorry sir, I didn't hear. Sorry. Oh, please. Yeah. Good question. Actually, in hydrothermal technique, we can get reproducibility result. For example, some salt gel or combustion technique, if you are making some nano particles, if it is some particular morphology like flower or something, rod or anything, if you are going with some other technique, we may not get the same morphology for if you are making it one more time. In this hydrothermal technique, if you are making we are following some things, right? Temperature and duration of heating time. If you follow the things, we can get the same type of material. We can reproduce the material. This is the highly main advantage of the hydrothermal techniques. Reproducibility. So this weight percentage, it will have a lot of calculation. I will send some calculation link because we have to maintain the mass balancing here. I told you the surface area is very, very important in this capacitor studies. So for making electrode, we have to maintain, for example, 2 electrode, we have to maintain the same mass loading for both electrode. Then only we will get good result, right? For that, we are using some asymmetric cell. We have to balance the both electrode mass balancing things. For that, we have to calculate some m plus m minus is there. I will send it to you. Please contact me. I have the thing. It will take another 15 minutes. That's why I'm telling. Okay, thank you. Yeah, only the conductivity studies. I already told you. We have to know the resistance behavior of our material. For example, first one is the solid resistance. First, the gap. The curve started from some small curve will come initially.
it will represent the RCT. RCT means it will represent the resistance of the electrode and that electrolyte solution interface. So from that we can easily see about our material conductivity. If it is, we will calculate the resistance from that impedance study. From that resistance, we can calculate the conductivity 1 by R, right? So that according to the conductivity study, we can analyze how our material conduct the ions or electrons. For that purpose, this is very, very important. Where is the resistance occurs? Whether we have a problem with electrolyte, or we have a problem with the electrode, or that interface, or substrate, where we have a problem, where we have higher resistance, everything we can easily find out from the impedance studies. Yeah, you can learn, but I learned from some well equipped lab. So I took that video from internet only. Usually we are doing these things in, I already told you, I did my postdoc in Indian Institute of Science, and I did another postdoc in SICRI. So those are my parent institutions. If I need anything, I depends both institutions nowadays also, because recently only I joined in Bharatiyar University after long back in my postdoc career. So after developing that pouch cell devices, I will call you. Before that, if you need, you can contact me. I will help you.
Okay, sir. Thank you, sir.
Vasant, where you are doing PhD?
Sir, I completed my PhD, sir, and now I'm working.
Oh, okay, okay.
In PhD, sir. PhD Tech, Coimbatore.
Okay, okay, nice, nice.
Thank you, sir. Thank you.
Thank you. Yeah, we can make it a coin cell. Actually, we are doing some special equipment. I mean, special device, reusable electrode device. I already told you, once we are making some electrode, I mean, device 2 electrode. After running some 10,000 cycles, I want to study some impedance things in this electrode. I have to remove that cell, and I can reuse that electrode. For that, I can use some special device. I didn't show here, but I have that one. If for the studies we can use some special cell, but if you are making some coin cell, means we cannot use, I mean, reuse that cell. But without the glow box help, we can use that coin cell. That is no doubt on that. We need glow box while we are using some lithium based material. That's all. Lithium are highly environmental affected material like sodium, lithium. Then only for perovskite solar cell also we used some glow box instruments, because it is easily absorb all water molecules from the environment. So it will affect the stability of the device. That's why we need some special glow box like that. But without lithium or sodium based perovskite based material, we can make a coin cell in normal room atmosphere, not an issue. Different composer, yeah. That's why we already optimized the thing in my SMG with Pani, right? So if we are carbon and we are mixing with some metal oxide or sulfide, we have to take a minimum amount of carbon based material compared to oxide or chalcogenates, because we are improving the behavior, capacitance behavior for sulfide or oxide based material. So if you add more carbon based material in that, that carbon based material character will exposed high compared to the oxide or chalcogenates based material. So you have to use little amount compared to our metal oxide and chalcogenate based material. 1:3 like that we can use. I used like that. I did so many device with various ratio, but 1:3 is better. Can you repeat, sir? Sorry, I couldn't understand. We can test. We can test. Actually, we have suppose sometimes we have some problem with our workstation. For example, our that crocodile tip may be contaminated. It may be corroded. If it is corroded, means we will not get a good contact with our device. For that purpose, we are using some commercially prepared, purchased capacitor here. So we will check using that capacitor whether it is working properly or not. If it is not working, means we will change that clip, crocodile clip, or we will ask the company people to come and check everything. So we can use, because research is the final end of the research is product, right? So you want to use product, you can check it, no problem. You can open the capacitor and you can check it. Because when I was in Korea, I opened the battery, lithium-ion battery in the glow box, and I opened that capacitor outside room atmosphere, and I checked everything. Then only we can do some research, fruitful research to get some product. You can do it. Yeah, okay. I clearly explained, even though one more time I can tell, the window is very, very important, right? For capacitance and you know the energy density formula, that is 0.5 into CV square, right? C for capacitance, V square means voltage. So we have to increase the value of capacitance as well as voltage. Then only we will get some good energy density. For increasing capacity, it will depend upon the various material which we have seen now, right? For increasing the voltage, we mainly depend upon the electrolyte only. So if you are using aqueous electrolyte, you know the thermodynamic decomposition voltage for water is 1.23 volt. If you are giving more than 1.23 volt, around it may have some over potential, it may evaporate around 1.3 volt. The water is splitted like oxygen and hydrogen. So we cannot use this aqueous medium more than some particular voltage window. If you want to use more than that window, we have to depend upon go with organic electrolyte. For example, lithium based material, we cannot use aqueous because it will easily catch fire if you are using water, right? So people are using some organic based electrolyte, lithium perchlorate. Then only they are going up to 3.5 volt that window. Okay, so for that supercapacitor also we can go with some organic based electrolyte. But in my lab, I am not doing that kind of things because it has some problem. It is we need some sealed type of device. Otherwise, that organic compound easily evaporated or easily react with moisture. So it has some problem with that. So if you want more energy density to increase the voltage window, you can go with some organic electrolyte, but you need some specific device. Usually so many people, they are using around 1 milligram electrode material on the substrate, but so many industry purpose, as well as I discussed with the superior professors, they told minimum we have to take 3 milligram. If you increase the mass, maybe it will reduce the capacitance. So people mostly they are using 1 milligram, but in my lab we are using around 2.5 to 3.5 milligrams of electrode. That will be give good result, I think so.
So good evening, sir.
Yeah, please.
So as you said, actually the aqueous electrolyte, which has a higher electronic conductivity compared than ionic liquids and ionic liquid electrolyte and organic electrolyte. How to overcome this?
Sorry?
Actually, what I say, as you said, the aqueous electrolyte will have a higher ionic electronic concentration. is comparison ionic liquids and organic electrolytes. So how
Yeah,
to overcome
it
this?
has.
Yeah.
Sorry.
Yes, sir. Your question is over. Just please.
So water have.
Actually, of course, electrolyte which has a higher electronic concentration. Yeah.
Okay, then next.
Other
Organic?
ionic liquids or organic electrolytes which has lower electronic concentrations.
Not like that, low electronic concentration. I'm not telling like that. We have a lower window in water, higher voltage window in organic electrolyte. Then like ionic electrolyte, everything have higher windows. But user friendly is water. Okay, I'm not telling water have much superior than organic electrolyte. If we want to use some organic electrode or ionic liquids, we need some specific and devices to characterize all those things. You know that one, right?
Okay, sir.
Am I right?
Yeah, sure, sir. Correct, sir.
Oh, thank you.
Thanks.
Sorry, sir. Here you see for 3 electrode, I want to give some example. For 3 electrode, we are making a working electrode and reference and counter. For example, manganese oxide we are making using as a working electrode. Suppose we are getting some 400 Faraday per gram capacitance while we are calculating 3 electrode setup, right? For charge discharge or as a cyclic whatever it may be. But at the same time, if we are making the same material using this 2 electrode, for that we are getting around 200 Faraday per gram. It will reduce half of the capacitance. So which one is the correct evaluation means this 2 electrode device. Okay. So if you are making a higher quantity of mass of electrode, it may suppress little bit capacitance, but I am not sure this is directly proportional to that. Okay. For example, in solar cell also, if you are make a small device, we are getting, for example, Dyson solar cell, if you are making small device, we are getting 10% efficiency. If you are go with some big model, like 30 into 30 centimeter, we will get around 5%, half of the percent efficiency. That means the resistance may increase. We are getting electron from the material to our substrate. It will take long time. Before that time, it may be recombined with electrolyte. We cannot utilize that electron. This is the reason we are not getting much capacitance while you are loading more mass. But we cannot tell directly proportional like that. I hope my talk may enjoy with you, not boring. And this is lunchtime, right? Everybody may feel sleep. Huh? Thank you, thank you. Thank you, thank you. Thank you, sir. Thank you, thank you.
Good evening to all. I am very happy to invite Dr. Murthy Chawli, Professor of Analytical Chemistry and Nanotechnology. He is presently working as Dean and Professor, Alliance University, Bangalore, India. And He received his PhD Tech in Analytical Chemistry 2000, Taiwan, Austria, and served as postdoctoral fellowship in USA, Japan, and Taiwan and NSC fellowship. And Professor Chavli has over 29 years of experience, research experience, and 23 years of teaching experience, and established 9 research laboratories. And he is a recipient of research prestation awards, fellowships, and commendation, and both nationally and internationally, and has been invited to several countries to speak on his group's research activities. He was recently awarded National Level Chemistry Award for Best PG Chemistry Teacher. Professor Dr. Budraya Chai Saxena Award 2020, given by the Association of Chemistry Teachers, ACT, India. He is also a visiting professor, researcher, scientist, fellow to 12 universities, institutions abroad. Dr. Muti Chavli has published over 310 articles in various international and national journals of high repute with high impact factors related, and presented his work in over 200 international and national seminars, symposia, conferences, workshops, and etc. He made a team contribution towards 12 patents, and he is responsible for 150 technical supports and 90 books and book chapters.
Okay, thank you. Is it visible? Hello? Visible. Can you hear me? Am I audible? Okay then. As the time is short, I should thank the organizers for giving me this opportunity to talk about hybrid supercapacitors. And since I've seen most of the lectures that people are being presenting in this particular national seminar, and I have to revise my lecture in terms of at least reducing some of the results, because most of the fundamentals and developments in supercapacitors and even the different types of material that they use in different types of supercapacitors are all being discussed over a period of 2 days, and people might be getting bored, and also time is short, as the organizers asked me to present it before 4 o'clock. I take this opportunity to brief you slightly about the other aspects, which are completely different from the previous lectures, where most of the eminent speakers have been talking about their results and what are the advances in different types of materials that are being used in superconductors, and possible challenges and opportunities that they have. And of course, I should congratulate the organizer for hosting such a type of CSS-sponsored national seminar at this time, where this is the need of the hour for developing research on supercapacitors and hybrid supercapacitors. In this particular lecture, I'm going to talk slightly, 1 or 2 slides, about the fundamentals and types of materials that are being used, and at the same time, I'll try to concentrate more on the markets, manufacturers, regional and global, as per the growth rate, as well as some of the information that is being given about the end user revenue forecast, and also some of the challenges and opportunities. Along with the talk will be concluded with some advantages and disadvantages. Yes, I'm going to concentrate more on a completely different topic where people have not addressed so far in this particular seminar. So, energy can be produced by various means: solar, wind, hybrid, nuclear, natural gas, etc. But the problem is the energy is efficient, and the produced one, is it utilized for a proper cause? And at the same time, storing energy is going to be very, very difficult. And at the same time, energy storing is a capture of energy produced at one time for the use at the later time. Means it is typically reducing the imbalances between energy demand and energy production. So all these things should be covered, and all these things should be taken care to have a portable specific device with a high energy density and also high power density, so that you will be utilizing it when it is required. So energy storing has a lot of benefits, like cutting down the operational costs, improving the reliability, resilience, and also having integration of diverse resources that are available to the mankind. And at the same time, the benefits do not come without any problems or demerits. Like it also has huge lags between storing of this particular energy and how this is being connected to the grid, unless until it is being used as a localized environment at the residential level, and at the same time the low capacity factor, which is also coming into picture. So all these things can be overcome by advancing ourselves or researching into different types of energy storage systems. Of course, when we talk about different types of energy storage systems, we have electrochemical, mechanical, electrical, thermal. Among the few research publications and whatever the research that we do in our research labs, what we have established before, we found that electrical energy storage system is one of the best, which contains capacitors, supercapacitors, superconducting magnetic materials, and also hybrid supercapacitors. So why? Because it has its own advantages, limitations. Coming to advantages, you must have heard so many things, like it has a very high specific power, low resistance, and also it is quite safe compared to other electrochemical, mechanical, and thermal. And at the same time, it also functions at the low temperature charge and discharge performance as well. So these things are one of the typical unique characteristics for electrical storage systems. But at the same time, it also has high cost per watt. I mean, this has been cannot be considered as a limitation, because this has come down drastically over the period of decade in the past. So in addition to that, it also has high self-discharge, higher than most of the batteries that they do exist as of now. So in one way, in adjacent along with these limitations, it also has advantages. So people try to use these type of things. What are the types of these systems? You have supercapacitors, like segregated into double layer capacitor, pseudocapacitor, and integration of these properties into two as a hybrid supercapacitor or hybrid capacitors. But these are also called as ultra capacitors. As you can see, the differentiation between double layer capacitor, pseudocapacitor, and double layer capacitor mostly work with the carbon materials in the nanotechnology regime. And in case of pseudocapacitor, it goes with connecting polymers and metal oxides. But if you integrate these two, you get a hybrid product, hybrid capacitor, super capacitors. But at the same time, again, these two also have different types of asymmetric, symmetric, which use the composite materials, and also hybridization between these two with a rechargeable battery type. And what is the most advanced one is rechargeable battery type. And it also has various other pros and cons. And if you compare these hybrid supercapacitors with as an alternative for lithium-ion battery, it also has its own pros and cons. For example, if you compare the battery with capacitor, if you take one parameter, energy, which is the best in the battery, and in the case energy, it is lost, but at the same time, it also has so many other parameters which are excelling over the battery, like weight, cost, charge speed, lifespan, materials. And of course, these pros and cons of batteries and capacitors were already discussed by the previous speakers, so I'm going to skip it due to lack of time. And as you know, if you take some of the parameters like charge time, it can be 1 to 10 seconds in case of supercapacitor, but in case of lithium-ion batteries, it goes up to 60 to even 2 hours. And the voltage, it's also much better, and specific power up to 10,000 cycles. And the cost, typically it was in the previous calculations, but it has come down drastically. This cannot be a factor when we talk about comparison of lithium ion and supercapacitor. Of course, self-discharge, you have 30 days, which is 5 to 40, and in this case, 5% less. And again, shelf life, it goes up to 15, and now most of the hybrids are going up to 20 years or so, which is not the case in case of lithium-ion batteries, which is 5 to 10 years. And again, if you talk in detail, and the time permits, probably we can talk about each and every parameter of supercapacitor with other things like lithium-ion battery, which is of very high cost, or lithium-sulfur battery, which is also have very poor rate of performance, and it might be low cost, but still it has some undue advantages or disadvantages compared to supercapacitors. And in the case of sodium-ion battery, also it is rich in sodium. Of course, it is not safe to handle like in the case of lithium. And in case of supercapacitors, they are very, very safe. Sodium mechanism is a hard carbon and is not clear in case of disadvantages of sodium-ion battery. But still, it is worthwhile investigating and comparing with the supercapacitors. Of course, if you talk about, you heard so many speakers talking about mass energy density, which I'm not going to go into the detail. The only reason why we talk about mass energy density is once you have this concentration, probably the lithium ion batteries or any of the battery that you take into limelight is going to be getting lighter, means the weight is going to be reduced. And if you take the volume energy density parameter, and it is going to be very small. Among the all lithium ion batteries is the one which is proportionately smaller and lighter, where it is much advanced than other batteries like lead acid, nickel cadmium, nickel zinc, lead metal hydride, and so on and so on, etc. So if you see the area, that is the applicability of this particular area, lithium-ion batteries over a period of diverse application, and it is the prominent phase of energy storage as of now, which will be overtaken by the supercapacitor and hybrid supercapacitor. This is one of the area where we wish to have supercapacitors developing in this particular area exponentially with lighter and smaller areas. And of course, if you talk about history, it started in 1996. I'm not going to go into the details, but way on and way forth, the leading country is the United States with a lot of things. And of course, Asia is also picking up with China and other countries, Japan and India. And if you collectively compare the supercapacitors and types of hybrid capacitors, you can call them as supercap batteries. Why? We have already seen in the previous lecture by Dr. Karthik, where he had explained about all these things. The one reason is we need to have something in the order of hybrid supercapacitor with very high energy density and that also at very high power density. That means you're going to have something in the order of here with the new development that are coming to picture in the next years. Suppose if you compare this, you have super capacitors with very high power density and you have batteries with very high density. If you combine these properties of these two, we can excel into hybrid supercapacitors where you have organic asymmetric supercapacitors, aqueous asymmetric supercapacitors, and symmetric supercapacitors. And among all this, the symmetric ones are at the lower end, because it was not exponentially proportional to energy density and power density. So we need to work in this particular direction by combining and preparing different types of hybrids so you can have different further developed hybrid supercapacitors with different proportions and patterns, where we have very high energy density and also we have very high power density. And if you compare this with the fuel cells are also much higher than batteries in terms of energy density, but they do not have any power density. So the next level is probably combining the properties of fuel cell, where the material that are being used for fuel cells with hybrid supercapacitor. Probably we can have something in the order of between hybrid supercapacitor and fuel cell, so that maybe we can expect something when people are trying to probe different areas to develop supercapacitors at the hybrid scale. And as we've seen in the previous case, you have different types of batteries. The one is lithium, which is being used heavily because of so and so advantages. But at the same time, most important thing, why we want to expel this particular material, because this is very unsafe, and most of the time when we prepare this, we need a glove box or some other precautions to be taken. So instead of having high power density, it has high energy density, but at the same time we need to have both the things. So we need to look into hybrid supercapacitors. What are these? They have they can recharge within seconds. They can be called as ultra capacitor, hybrid supercapacitors, and they can be working at the elevated capacitance and also elevate the energy storage capacity of the system. So all these things are very much possible. As I said in the previous, we have different types of hybrid supercapacitors, like symmetric hybrid, because two composite materials, symmetrical arranged between them with around a separator, which is called as symmetric composite material or symmetric supercapacitor. And if it is unsymmetric, we're going to call as asymmetric hybrid supercapacitors. And if it is a battery hybrid, then we call it as battery type hybrid supercapacitors. One of them is the best. And if you see these 2D materials in the hybrid supercapacitors, they use MXenes, transition metal dichalcogenides, and phosphorins. All these things have different applications. In symmetric, we have 2D transition metal dichalcogenides, and in asymmetric, we have 2D MXenes, which is the top in different areas in nanotechnology where people are working on this. And also, they're trying to implement this in hybrid supercapacitors to elevate the capacity of energy storage. And another important one, which is at the highest level, is usage of 2D phosphorins as a battery type hybrid supercapacitors. So at the same time, you have losses, and the losses are only at 5% of its energy, and it is comparably much less than a battery where it is 50% or more. And in case it can also be highly efficient, a new hybrid capacitor increases the energy density to 115%. Means it is just by taking the properties from electrical dye-label capacitor plus combining or integrating that with lithium-ion technology so that you can have energy density as high as 115%. So all these things are very much possible. And as we say, we have to look into developing some of the materials with power density and energy density. The one is hybrid type supercapacitors. In that you have CSH, EDLC, BSH, and pseudo. Pseudo is nothing but with pseudo capacitors dominant, and battery type supercapacitors with lithium ion cells, and electric double layer capacitors, and capacitors with double layer capacitance, which is again dominant. So among all these things, you can see BHS battery supercapacitor hybrid is much more higher, and people are trying to work with this so that it has a property which is much higher in terms of power density and energy density. By 2030, probably this could be the new type of material or battery where we can use a lot of energy storage devices in different applications. So if you talk about market research, there are several companies that are being producing. China is the one which is leading in all the things. And if you talk specifically about the percentage levels, of course, Asia is leading, but quality-wise, US is catching us up in terms of different types of materials, because most of the research is thrown in either China or in Japan or in the US, and which is accounting for 25%, and Europe is far behind with 11%, and others contributing very low, just 1/10 of the entire thing. And this trend is going to be changed, and everything is going to be Asia Pacific region, where people are trying to establish a lot of EV type in different applications. And if you see the market by region in North America, Europe, Asia Pacific, and rest of the world, the leading one is Asia Pacific region with a lot of things. And if you compare the whole, the market has been risen by 409 US millions from 2022. It is expected to be 2025. As of now, it is around 600 or 550, between 550 and 600 USD as per the region. That means it is picking up, but research-wise, maybe it is due to the pandemic and so many other reasons, but still it is picking up a lot, and it is going to give us by CAGR, compound annual growth rate, of 12 to 22%. It is also varying because different companies have surveyed in different ways. And as far as the market size is concerned, it is going to be like 15.9 billion by the end of 2027, or it is even expected to be 10% higher than the estimated amount of 15.9. If it is 10%, probably we can think of something in the orders of 17 million by 2027, rather than something which is as said as 15.9. And if you talk about different types of supercapacitors, and it is going to be something in the order of 2020 to 27. And if you talk about the market region, and again, see, you can see it is as 23.20% in CAGR, compound annual growth rate. But it has various people that have been estimated from different types of industries. Probably automotive industry, if they gain, probably they can say it is 22.2, or industrial application people, they must have guessed it to 22%, so on and so forth. But definitely it is going to be and something which is in the order of 20%, so that people can gain a lot of challenges, people can address a lot of challenges, and at the same time you can also address so many other potential things or opportunities can be gained by understanding this market size, and so people can be working in that particular area so that your research can be, say, the sponsored or elevated from the ordinary level. And this is also another estimate which is for the Asia Pacific region, where the growth rate is not as comparably higher than the average, but still it is 12%, but that is up to 2025 only. If it gains, probably it will reach up to 2027. Probably it can go up to 19% because of the usage and the research that is being impounded for developing these hybrid capacitor segment. And the market can be projected in a very, very huge way during that particular forecast period from 2025 to 2027. And again, if you talk about India, which is far behind many of the countries, but still in India, we have supercapacitors mainly in the area of consumer electrons rather than automotive or industrial sector. This has to be changed, and consumer electronics is going to come down with the usage of supercapacitor, but at the same time, it is also trying to gain in automotive and industrial sectors. So all these things are one of the best way to understand and to invest more in supercapacitor research so that it will be highly useful. And here also you can see it has been diverted from automotive industry, consumer electronics to automotive industry, which is 30%, and it is also going to be much, much higher compared to the 2016 market. But now there is a dip because of the pandemic, but still by 2022 or 2023, the market related to automotive industry is comparatively much higher than anything which is like consumer electronics or industrial sector. If you boost up an industrial sector, that means you have to increase the power density and the energy density of a supercapacitor so that it will be implemented at a lower cost. So if you talk about the revenue, it is going to be something in the order of a few hundreds of millions from 2008, 400, probably it is reaching up to 720 or so. But still, there are dips in between, and there is also dip that this particular area is due to the pandemic, and this we don't know why it is, but still it has gone down drastically, maybe because of lack of material that is being used in developing these things. But still, if you talk about revenue by 2027 to 2028, it is going to be very exponential, and probably by instead of 2027, 2028 is going to be the very precise beneficial year for supercapacitor, where the market size is going to touch and cross $1,000 million by 2027, and probably this can be achieved even by 2027 as well. And if you see the supercapacitor market, you are at the present of 2.92 in 2021, and this is likely to be raised in 4 years by almost 4 times. 400% is going to grow, and this is also very much possible because the way at which steep research is going on in developing different types of products and materials into the market, this is very much achievable. And this is just a forecast for 2022 and 2025. But still, this is an achievable forecast, and as predicted, plus or minus 1%, it is going to grow into that particular area. And again, this is the comparison of various sectors in the vertical sector. And again, it takes a very important role for automotive industry, which is very much essential rather than having consumer electronics for supercapacitor market research. And coming to the publications, it also has a lot of publications, which has gained over a period of 2 decades with a dip. And this can be uh, compared to the dip in products and market revenue in previous slides, which is in 2015. But still, people are working effectively, enthusiastically, encouragingly in these particular years of pandemic 2020, where you have 3,261 publications, and 21 it has been risen by 10 more percent to 39, 35, and even 2022 still pending to be published or around 175 publications. That means it's a good sign for people who are trying to understand the necessity and requirement and trying to address the challenges and take it as an opportunity to develop the supermarket research. And you also have so many problems, challenges in industrial standard preparation, and also creating electrical parameter models where these materials, how these materials will behave in a supercapacitor. And also consistency is also key, so that stability, reproducibility, all these factors will account as a challenge, and some of the technical problems are also will be added upon. So that will give a lot of area for new novel, innovative researchers to come in and gain some access, with having so many opportunities lined up in the years to come by 2030, where you need to have a flexible supercapacitor, rechargeable, fast, and also with high power density, and also with very high energy density. And definitely by 2025, it is going to be 20%. That means we are going to be on track with 28% by 2030. And coming to the opportunities, it has several opportunities in improving or modeling against flexible and miniaturized supercapacitor, and at the same time on the product, where we have combinations of double layer pseudocapacitor, hybrid capacitors, etc., and different types of modules that is required for the industry, automotive, and consumer electronics. And all these things can be taken up, and these are some of the opportunities where youngsters can do some research upon, so that it can be utilized as per the application specific. And coming to environmental impacts, it has environmental impacts, but at the same time, it is not going to be that very high as compared to other materials like batteries or battery hybrids. So we can think of this as an attractive option in using either at the residential level or industrial levels, because supercapacitors are going to be very promising with high power, fast charging, and environmental friendly. And of course, utilizing MXCNs to the transistor metal dichalconides and graphene-based, nanotechnology-based TMD supercapacitor. Furthermore, it will not only develop these into different types of hybrid systems, but also they are going to be very much environmental friendly or eco-friendly. Of course, I'm going to skip this because most of them have been repeated from the previous sections and speakers, and also from my side. The one thing is it has a very high capacitance, fast charging ability, and highly reliable, and at the same time reduce the size of the battery consequently. And also these merits also come with disadvantages. And if you try to apply some of this carbon nanotechnology into it, can be a green anisotropic polyaminide copper oxide as a material for this hybrid supercapacitor. And also people can study utilizing different material for solid state supercapacitors as a hybrid for high energy power density. And of course, as we discussed, 2D materials and powerful graphene hybrid material for highly efficient supercapacitors. And these can be improved into a next level, or by the order of tenfold or multiple fold, so that these can be acting as a green and clean hybrid supercapacitor. And by 2030, probably you'll have six more different types of hybrids that are emanating from the research of this day. So we have seen the potential of supercapacitors in industries and fields, and of course, it is trying to be exponentially growing at 45-degree angle in terms of energy density and power density. And of course, nanotechnology, nanoscale materials can offer new types of exciting fields of research in supercapacitor hybrids development in various areas. Probably like dual metal oxides or triple metal oxides, probably this can be combined. And the goal is to expand the application field of supercapacitors and reduce the cost, improve energy density, and also power density. Finally, the greener and the cleaner devices are much more better. And I do hope with this level of research and enthusiasm in the world, with the market size and applications that are proving us to be more challenging and given different types of applications, I can suggest that these are some of the exciting times we had for hybrid superstructures in the future. And with this, I'll conclude my talk. I think I'm within time. I conclude this with some of the references that I've collected in preparing. I mean, very urgently, just 2 days behind the schedule. And with the conclusion, I acknowledge my team, my sponsors, my students, and my collaborators. Thank you very much. I think I'm within limits, right? If you have any questions, I mean, this is not an experimental paper, but these are all general papers which I've covered. Because experimental paper, if I give my results and the graphs, probably it might be boring for you. So I thought change a little bit into market size and other things. Okay, any questions, please? Yes. No, yeah. Thank you. Thank you. Thank you for inviting me. Yeah. Thank you.
Is it audible, sir?
Sir, 1 minute, Principal Sir will join.
Okay, ma'am, okay.
So let's wait for a minute. Let Sir also join. Principal Sir also. Oh, okay.
Yes, sir. Sir has joined us, sir, Principal, sir.
Join, ma'am.
Good evening and warm welcome. Thank you all for making this two-day national seminar on state-of-the-art and future perspective of hybrid supercapacitor for greener environment, a successful outcome. We feel all of you have benefited in one way or another. Of course, all important things come to an end. Likewise, our August function too will end in an auspicious note with a valedictory function. With these words, the success behind her is of strong willpower, balanceable person, and at the same with good administration in any sector, making her to grow higher and higher to attain the success. This suits our madam. May we invite Dr. S. Shalini Baikan Kamala, Head and Professor of Science and Humanities, Nehru Institute of Engineering Technology, to welcome the gathering.
Most respected chief guest of the session, most respected principals, respected deans, directors, heads of the departments, AWOCOM HR, faculty members, and enthusiastic faculty participants, and my beloved student participants. A pleasant evening to you all. I welcome you all to the fifth CSIR-sponsored seminar from the Department of Science and Humanities. CSIR sponsored 2 days national level seminar on state of the art and future perspective of hybrid supercapacitor for greener environment was successfully conducted with 10 renowned resource persons for 160 participants from 101 institutions in Google Meet along with YouTube streaming. The enhanced role of supercapacitor was explained very well, making the impression of Nehru Institute of Engineering and Technology in the revolution of energy field has started happening. This is because of the efforts taken by Dr. P. Periyasamy. Tons of appreciations to you, sir. At this juncture, I am happy to welcome our CEO and Secretary, Dr. P. Krishna Kumar, who is the CEO and Secretary of Nehru Group of Institutions, Kerala and Tamil Nadu, in his absence here. It gives me immense pleasure to welcome Dr. Murthy Chavli, Research Director, Alliance University, Bangalore. We are delighted to have you amongst us, sir. Your session was very informative, though it was very short. We all were involved fully, and you gave a lot of information. Hearty welcome to you, sir.
Thank you.
And I extend my heartfelt welcome to Dr. P. Maniarasan, Principal, Nehru Institute of Engineering and Technology. A special note of welcome to Dr. M. Sivaraja, Principal, Nehru Institute of Technology and Research Director of Nehru Group of Institutions in his absence here. And I welcome all the deans, directors, heads of the departments, AO cum HR, and faculty members of NIET and NIT and all Nehru Group of Institutions. A warm welcome to and a lot of wishes to the faculty participants from Kashmir to Kanyakumari who made the seminar a real national level seminar. And I welcome and appreciate all the student participants. Your enthusiastic participation, that is your interaction in attending the sessions, it will surely make you a good researcher. Welcome you all once again. Thank you.
Thank you, madam. The positive person always encourage others to go for success. Our beloved principal of NIET motivate and encourage the students and faculties to enrich the knowledge to grow higher and higher with the consistent hard work in a smart way to reach the pinnacle of success. May we invite our beloved principal of NIET, Dr. P. Maniarasan sir, to present the special address of the day.
Thanks, madam. Most respected chief guest, that resource person as well as chief guest of the day session, Professor, the Honorable Eminent Professor Muthu Chawli sir, and head of the department, Dr. Shalini madam, and coordinator, Dr. Perisami sir, all the faculty members, the faculty member from other institute, research scholar, and everyone present here, very good evening to all. Maybe the 2 days, that wonderful seminar in the area of the supercapacitor, we are winding up. It is whatever the time limits, our professor and our HOD madam, they taken the pain and strain, arrange the program for the all research scholar. This a short span of time, our eminent speaker delivered the maximum and whatever the happened, what are the practices, how we can able to utilize the supercapacitor for the energy storage device in more explained manner. Anyway, my request to all, this is a time we have to think about this green environment. What are the invention happening? We have to think in a different way. Maybe we are thinking that the electric vehicles or something else, they are not polluting the atmosphere, but manufacturing the electrical devices, storage devices, again it is speaks a lot. That again, that my request to this type of webinar and all, it will be going to enhance our the research forum and our taking that innovation to the greener environment. My sincere thanks to because of the management, faculty, our chief guest and the resource person of the day, Dr. the eminent person, Murthy Savle sir. In spite of busy schedule, sir has accepted an invitation and he shared his experience to the maximum way in the area of the supercapacitor. And my sincere appreciation goes to the organizer, HOD madam, and Dr. Periyasamy sir, and all the coordinator, the faculty members, those who have taken the pain on their head, the shoulder, and they meticulously arrange the program for all the research scholar, all the teachers. My sincere request, and this science is known science is only 10%. I always used to say we are moving from known science to unknown science. That is forum is called a research. Maybe we have to continue our journey until our death period, and we have to do the best for our nation. Once again, my sincere appreciation goes to all the participants, the organizer, and with the help of them only, we made this the grand success. Once again, I wish you all the best. God bless. Thank you.
Thank you, sir. May we invite our chief guest and distinguished speaker of the day, Dr. Murthy S.S. Chawali Yadav, Research Director, Alliance University, Bengaluru, to present the valedictory address of the day.
Thank you all. Respected principal, sir, respected HOD, and my dear friend, colleague, and the organizer, Dr. Periswamy. Thanks for having me here. And this is a wonderful experience and a wonderful event which has passed on for most of the researchers that are coming from north to south of India. And this is one of the area where South India excels in electrochemistry. and organizing such an event at a big scale for 2 day and having eminent speakers from many research groups in electrochemical field is also another great thing. And also thanks for having me here. My sincere advice is not to stop at this level. Probably expand this into the next level. Probably you can have one nanotechnology based research center where I was also doing the same things. Over the period of time when I came back to India, I was establishing different labs at different places, and they're all doing exclusively well. And some of them they got a NAC A plus grade just because of having one laboratory of a few crores. And that will be one area where you can promote research, where you can gain popularity, increase your admissions, and also increase so many other things by establishing this particular advanced research lab with little investment from your side, and also from faculties can bring in some of the grants from government side. So my sincere advice will be to get into this. And of course, most of the people must have gained some knowledge. I can say 100% they've gained a lot because of the diverse field of the speakers. And in fact, myself, I have to change my topic after seeing all these lectures and the titles. I had to change because it will be like a repetition and it will be boring for the audience to be at the last speaker, being the last speaker. So today morning, I have changed everything, coming back to the market challenges, opportunities, and some of the fundamentals with new materials that are being used in superconductors. And this is one of the best platform to address and also highlight NIET for the years ahead, not to rest with the success of this particular event. Go continuously once in 2 years or once in a year. Get the sponsorship from CSR and other institutions. And also, you have a wonderful faculty members, and you can also go ahead with organizing some of the research laboratories in especially basic sciences. That will translate slowly into applied sciences, engineering, and technology. And since you have chosen hybrid capacitors or electrochemistry, where people are trying to integrate this with nanotechnology, probably it would be very good for you to have advanced nanotechnology based research center for diverse applications in chemistry, physics, materials, biology. Of course, biology may not be there with you, but still some applications like in bioanalytical biology, antifungal studies, and all this can be done by having just one lab. If you can promote that, that will be an excellent thing. And also, I thank once again the management, the principal, and the coordinator for having such an opportunity in this area in a short notice of time. And I do give on behalf of this valedictory address, my support will be there in any form, whatever you need. And also, if you need any assistance from our side, you are most welcome. And I'm also very close by, unlike previous years where I was in Andhra Pradesh. Now I came back to Bangalore. And we are also trying to establish something in the order of 50 crores, one research center. If that is there, probably we can join hands in doing something. And once again, I congratulate you for having this wonderful event on advanced supercapacitors. And this will help everyone, and it will also gain a lot of popularity. And I wish you excel in this particular direction in research in nanotechnology and hybrid supercapacitor. Thank you and wish you all the best. Thank you.
Thank you, sir. Now it is time for feedback. Dear participants, kindly come forward to give your feedback of the two-day national seminar sponsored by CSR. Participants, please come forward and give your feedback. One or two may please come forward and give your feedback of this national seminar sponsored by CSR.
Good evening, one and all who are physically present here. I'm Dr. David Kribagaran, working as assistant professor in KSR College of Arts and Science for Women, Tiruchenkodu. I really enjoyed my time at the national seminar. Really, my heartfelt thanks to all the resource person. They have bare enough to explain the concept and future perspective of hybrid supercapacitor, and also being very patient enough to answer all the queries which is raised by the participants I'm sure it was a hearty, healthy, and discussion, and also useful for the research forum. A special note to Dr. Periasamy sir. Thank you for hosting such a wonderful seminar. I'm looking forward to upcoming either seminar or conference in the form of multifunctional application